Okay, so here you can see the first thing is to understand the course title. So our main course title is Electrical Designing and the Drafting. So before going for the course, we have to understand why we have to opt and why we have to work for the electrical area. What is the basic importance and necessity for any MEP projects or for any kind of construction projects. So electrical designing and the drafting. These are the three words, or I can say as three acronyms, which will give you the platform to work as electrical design engineer as well as a draftsman. So before starting the session, let me introduce myself. Myself, Muhammad Abdul Wajid Mudassir, the concerned faculty for the complete course Electrical Designing and the Drafting. I'll be dealing with the designing, I'll be dealing with the drafting along with the simulation softwares like ETAP as well as the dial. So I'm the concerned faculty for the complete course. Alhamdulillah, I have got multiple years of experience in the MEP area, especially in the electrical. I have done many projects across the globe. Almost like 3 countries I have covered. One is the UAE, the Saudi Arab, as well as the India. And on the first day itself, I'm telling you, soon after the class, if you practice, it will be much good for you to understand the complete course, because we have many people who works only on the weekends, especially for these courses. So please try to work soon after the class. So the first thing is to understand the course title. So this course is having the acronym of 3 words, nothing but the electrical designing and the drafting. Okay, so what is mean by electrical? Nothing but the study of electricity. Study of electricity. Whenever you're going to work for any project, the first thing is to provide electricity. Many engineers, what they think is a rule of electrical engineer will come once the complete structural work is done, but it is false. We as electrical engineer, our role as well as the responsibility start from day one of the project, because we are the one who is going to provide the point of supply. So if you have a point of supply only, then you can able to work with your machines, your motors, or with your cranes and the lifts. So many of us will have a conflict that after completion of structural work, we as electrical engineer, we are going to work on site. It is totally false. So from day one of the project, we are going to work on site by providing the point of supply, proposing the size of transformer and different cables, I can say. So in this area, we are going to study about electricity as well as the electronic. Nowadays, you can see we are transporting electricity by using some different electronic devices, and we are totally dependent on electronic devices itself. All the devices earlier which used to work with electrical area, now it has been converted into the form of electronic area, because in electronic area the efficiency is very good. The losses are very less. So the complete area has been shifted into the electronic as well as the control system area. The next thing is the thing but to understand about the designing. What is mean by designing? In simple words, I can say that designing means performing calculation. To perform calculations. For example, I'm working with a project. So when you're going to work with any project, you are going to provide some calculations. You are going to propose some devices. All those things you're going to develop once when you have some basic technical background. You may be from any background. It can be a mechanical, it can be electrical, it can be control system, or it can be your electronic area. But we need a certain background to work with the design area. So in designing, we are going to perform calculation. I am working with a commercial building. So in a commercial building, you can see we have different electrical devices. We have different electronic devices. So to provide the reliable supply along with the continuous efficiency, we are going to propose the accurate size. The undersize of a device, the oversize of a device will decrease the efficiency as well as the reliability of your project. So as a designer, what we are going to do, we are going to propose the equipment sizes. Again, next we have the area called as drafting. What is mean by drafting? Drafting means drawing, I can say. In technical term, we call it as a draft. In common day-to-day life, we call it as a drawing, I can say. So this electrical drafting is actually a technical drawing, which will provide the information about the complete design structure. Drafting means a technical drawing which will provide the complete schematic layout of your design area. So this drafting is classified into different layouts, like we have a lighting layout, raw power layout, control system layout, circuit wiring. Okay, we have the single line diagrams, we have load balancing schedules, multiple things we have. So all these things we are going to work with your drafting. So this drafting basically, earlier we used to go with manual way, but now because of advancement in the software area, we're using some applications and the tools like AutoCAD, or you can say as a MicroStation. We have different tools. Earlier, almost like some 15 to 20 years back, we used to go with the softwares, we used to go with the manual way, but now totally we are going with tools and applications like AutoCAD or MicroStation, you can say. So these are the three things what we are going to learn in the complete course. I hope it's very clear. Yeah, Mr. Ahmed.
Sir, what is the meaning of raw power?
Raw power means if you are working with heavy loads, in that case we call it as a raw power.
If you are working with heavy loads?
Yes, if you are working with heavy loads, for example, if the equipment is having a wattage more than 200 watts or even 100 watts, so some standard, if the equipment is having a power consumption from 100 watts, in that case that is going to be placed under the raw power area.
Oh,
we are going to discuss about all those things in the future classes. Next, we are going for the next slide. Here you can see the introduction and the workflow of building industry. Yeah, hello.
What is the syllabus of this course, sir?
I'm going to come for that. The last slides, we are going to discuss about the complete syllabus. So next you can see the introduction and the workflow of building industry. That means whenever you're going to work for any project, so how you're going to initiate your work and how you're going to propose all your devices. This is a main important thing. So for example, you're working as a consultant or you're working as a design engineer. So what are the roles and responsibilities and how we are going to work for any project? This, if you are very clear, then you can able to work for any project. It can be the industrial, it can be a commercial, it can be a domestic, it can be residential building or any kind of villa or a venture. So the first thing, whenever, for example, if you are having a dream, okay, to make a high-rise building. So what you are going to do, you are going to approach a consultant. You're going to meet a consultant. What is mean by consultant? Nothing but a group of engineers working in a team is called as a consultancy. A group of engineers. Here you'll be finding a people, okay, from different backgrounds. Okay, in a consultant company, you'll be finding civil engineer, you'll be finding a mechanical engineer, you'll be finding the interior designer, civil architects, multiple people you'll be fine. So in a consultancy, we have a group of engineers, and this consultancy nowadays we are calling it as an architect. Earlier we used to call it as an consultancy, but now we're calling it as an architect, because this architect will have the contacts with each and every individual department people, and he will be having a scope to work for all the. Earlier we used to call it as a consultancy, but now we are calling it as an architect. So initially, whenever you're going to work for any project, what is the first thing you're going to do? You are going to check the soil bearing capacity, which is called as SBC. The structural people can able to understand this very clearly. Soil bearing capacity. For example, I'm proposing a project for 20-story. So if you doesn't know the soil bearing capacity, and if you're going to design the complete 20-story building, so what happens? Okay, it is waste of time. So first we are going to check that the proposed land will have that much amount of soil bearing capacity to withstand that much amount of load. If you'll be finding that much amount of capacity, then again you are going to proceed for the design area. For example, if you have done the calculations for the complete 20-story, afterwards you have came to know that the soil cannot able to withstand that much amount of load, means it is a waste of time. So the first thing is to work for the soil test department. So this people will see what type of soil it is, because we have different types of soils. We have hard soil, we have moram soil, we have the black cotton soil. Okay, we have different types of soil. We are going to check what type of soil it is. Again, survey of area. We are going to make a survey. For example, if your site is located nearby to any kind of defense area or any kind of archaeological area, okay, or you'll be finding a project nearby to the airports, so these people will not give you the permit to go for the high-rise building. So along with that, you're going to check, you're going to make a survey also. And different countries, different cities, and different localities will have their own standards. We are going to follow that also. Again, we are going to measure, because the land area will always not be in a square shape or rectangle shape. To go with the simple formula, area of rectangle length into breadth. You'll be finding the lines with some different ends. Sometimes you'll be finding some 25 sides also. So this people can able to work for the complete area in a very clear way. So the first thing for any project is to check the soil bearing capacity. Next thing is to work with your civil department. So once the soil bearing capacity is clear, then again the role of civil engineer will come into picture. So why should we have a civil engineer in any construction company? Design the structure or the skeleton of the building. What is meant by structure? All the load bearing components. Okay, like we have the column, we have beams, we have slabs, we have different membranes. So all those things they are going to propose as per the type of load we have in the building. Again, they are going to propose the walls also, because we have different types of walls. We have parapet wall, we have compound wall, we have partition walls, we have different materials also to construct the walls. So these people will guide you what actual type of material you have to use. Again, placement of doors and windows. So as per the ventilation point of view, okay, as per the orientation of your plan, they are going to provide the entrances. Okay, they are going to provide the windows and the ventilators. So all this comes under the scope of a civil engineer. Then again, the work of MEP department. So MEP stands for the mechanical, electrical, and the plumbing. So this can also be called as building services. So M stands for the mechanical, E for the electrical, P for the plumbing. For example, if I'm going to make you to sit in a room where you have a temperature of almost like 55 degrees centigrade, or if you are in a building where you don't find any kind of proper electrical supply, nor any kind of water supply. So can you able to survive for the longer time? No, we cannot. So we as human being, okay, we need some human comfort levels. So that to maintain the human comfort levels, we require this MEP services. What is the human comfort temperature? This lies between 22 to 25 to 26 degrees centigrade, I can say. And as electrical engineer, we are going to provide the reliable supply. And as a plumbing engineer, we are going to provide a continuous water supply also. So all these things comes under the MEP, which we are going to understand in the future classes, inshallah. Next, we have the interior designer. So you will not find the interior designer in every project. When you're working with commercial projects, when you're working with big projects, there only will be finding the interior designer, because these people, especially they work for the aesthetic point of view, for the beauty point of view. When you're working with hospital, so there you cannot go as per your own requirements. We have some standards, we have some certain rules. So these people are much aware about the rules and regulations, like which type of color is suitable, what type of furniture, how to utilize a maximum amount of space. All those things, they have a bright knowledge as well as a vast knowledge. So they are going to propose all those things like wall paints, wallpapers, furnitures, fall ceilings, landscaping. All these things are proposed by your interior designer. Then at the last, what we have is nothing but the miscellaneous department. This is extra human comforts. Like when you're working with some luxurious villas or any kind of luxurious buildings, there you can see you'll be finding the automation. Like whenever you're going to enter, the doors will open. Whenever you leave, the doors will close. The means of your electronic gadgets like your mobile phone, tabs, systems, you're going to operate all your appliances. So all those things comes under the home automation. Again, we have the building management systems and services. So this is a separate area, especially when you're working with commercial projects where you have some multiple number of fixtures which you cannot troubleshoot, which you cannot operate manually. So in that case, we are going to use a technology called as building management systems or services. So this is actually the area which will help you to maintain and troubleshoot and monitor also. So this is a complete flow to work for any project. I hope it's very clear regarding. Next, you can see the topology of the building surface. Topology means what? Especially we are briefing into the MEP area. So the first thing is to discuss in the mechanical. So as a mechanical engineer, what is the main objective? For example, I'm working with a construction company. So why in a construction company, we need a mechanical engineer? What are the rules and responsibility? The first thing, we have a department called as HVAC, heating, ventilation, and air conditioning. Okay, many of the electrical engineers will think high voltage alternate current. It's false. In the mechanical, it is actually the heating, ventilation, and air conditioning. So as I have told you that we have to maintain the human comfort temperature, which lies between 22 to 25 or 26 degrees centigrade. So in order to maintain this, we require the centralized air conditioning system. So what is meant by air conditioning? controlling the properties of air, because in air we have different properties. We have humidity, we have moisture, we have odor, we have temperature, we have different properties. All those things we have to control. So the first thing as a mechanical engineer is to find out the heat load calculations. We have different concepts to find out the heat load calculations based upon the CFM requirements. You can go in a manual way also, or you can go with the softwares or applications also. Again, the basic thing what we have to understand in the mechanical area is the refrigeration concept, because this is a basic fundamental thing what we have to understand. Again, the means of psychometric chance, we are going to work for the project. Air distribution system, how we are going to distribute the air. Ventilation system we don't require in every project, some projects required. Again, the static pressure, hydronic system, duct sizing, HVAC software. So all these things we are going to work by using the HVAC softwares. Different manufacturing companies are having different applications. So by using those applications, we are going to propose all the HVAC equipments. Next, you can see the plumbing department. Nowhere across the complete globe, I can say, we have a specialization or engineering called as plumbing engineering. Especially, the people from the mechanical background or even from electrical background can able to work for the plumbing department. Earlier, almost like some 15 to 20 years back, it was the scope of a civil engineer. But now, because of advancement in the plumbing, the fixtures, so the role of mechanical and the electrical engineer is also very important. So as a plumbing, the first thing is to find out the complete load, the complete demand. Then again, we are going to make different layouts, like internal layout, external layout. The name itself indicates whatever the fixtures which we are going to propose inside the building and nothing but the internal fixtures. And whatever the fixtures which we are going to propose outside the building, like in the outside area, what we have the overhead tank, we have the underground tank, we have the manholes, we have sewage lines, we have the rain harvesting pits. All those things comes under the external layout. So why we are just segregating all these things? To work in a very simplified way. Again, we have the firefighting system to provide the safety for your building equipments and property, as well as to ourselves also. This is also a separate area in the plumbing. Again, we have the rain harvesting system to increase the water table, safety and health environment, because nowadays we are going to work in a very safe as well as a healthy environment. So we have some certain things also which we have to learn ourselves to save the environment. Again, the sewage treatment plant, if you want to recycle the water, if you want to reuse again the same water, we are going to treat the water. This concept is actually very important when you're working with the projects where there is a water scarcity or a shortage of water, you can say. So these are the things what we have in the plumbing. The last thing what is left is I think but the electrical. So as electrical engineer, what we are going to do, we are going to work to find out the total connected load. This is very important. Okay, as an electrical engineer, first thing is to work to find out the total connected load, after which we are going to propose a single line diagram. What is meant by single line diagram? It will provide you the schematic flow of power, like from which point, how we are going to propose the supply for different feeders, for different branches, as well as for different circuits. By means of single line diagram, you can able to understand the complete concept of your project. Again, we are going to make the layouts like lighting layout, raw power layout, air conditioning layout. Air conditioning layout is not a scope of electrical, but if there is a requirement of a split AC or window AC, we can able to work for the air conditioning also. But basically, whenever we are going to work for centralized, we require a mechanical engineer only. Again, we have the conduits. Okay, nowadays we are going with concealed wiring also. So we are going to propose the conduit layout, control wiring or the circuit wiring. Again, we have the low current system area, where we are going to work with the CCTV system and the public address system. So this is a major scope of electrical. Now we are going to understand in detail about the electrical in the next slides. So before going for next, if you have any query, you can please clarify. Everyone, please.
Just out of curiosity,
Yes.
so electrical, are we also covering fire alarm, or is it under
No.
fire?
No, it is with the separate area, firefighting area.
Okay.
Next, about the power flow analysis. Okay, so in this, we are going to understand that how actually the power is coming to our lighting switchboards and how we are running our devices like laptops at present. So we are getting the supply from the substations. We're not coming from the generating plants. The supply to the substation comes from the generating. In different cities, in different areas, we have different types of generators. So we are not going to go into the generating area. We are talking from the substation. So in every locality, in every society, based upon the demand, we have a substation. So what is meant by substation? Assembly of all your electrical, the switchgear and the control system devices is nothing but substation. So in this substations, what we get power. So this power is classified into three types. One is the active power, apparent power, and the reactive power. About the power, we are going to discuss in the future classes in detail, along with some examples, along with the basic formulas. So at present, you can see that power is nothing but the product of voltage and current. Okay, so this power we are getting to the transformer. Okay, so what is a transformer? Okay, what is a transformer? What is the basic function of a transformer? You can see the transformers on the roadside, in substations, in your projects. What is the basic thing? To step down the voltage and to maintain the frequency, you can say. So these transformers are classified into three types. One is a power transformer, distribution transformer, and the instrumentation transformer. So what is power transformer? If the capacity of transformer is more than 3 MVA, then in that case, we call it as power transformer. And this power transformers you can able to find only in substations, not at distribution site. Again, we have distribution transformers, the transformers which you can see on roads, which will provide you the supply, okay, to your building. Those are your distribution transformer. Again, we have instrumentation transformers. So this is actually a type of transformer which will help you to measure the amount of current and the voltages. Okay, so in this instrumentation, we have classification called as current transformer and the potential transformer. After transformer, we get the supply to the productive equipments like circuit breakers. Earlier, we used to have the fuses, but now it is outdated. We are going with circuit breakers. We have almost like 5 to 6 different types. Okay, we have miniature circuit breaker, molded case circuit breaker, air blast circuit breaker, vacuum circuit breaker, oil circuit breaker. Okay, again, the sulfur hexafluoride circuit breaker also. We have different types of circuit breakers. About all the circuit breakers, we are going to discuss in the future classes. Next, okay, we get the supply to the measuring equipments, nothing but your energy meters against how much amount of power you are consuming based upon the tariff rate the department people will charge you. Okay, on monthly basis, you can see you'll be finding the electricity bill now. So that we are getting based upon the energy meter or the power consumption. Again, the supply comes to your distribution board. So based upon the type of project, you're going to propose the main distribution board or submain or distribution board. So this is the complete schematic flow of power. How actually we're getting the supply to our lighting switchboards to run your electronic gadgets, lights, fans, and the basic things. I hope it's very clear. Next, you can see the steps involved in electrical designing. So as electrical designer, okay, how we are going to initiate our work, how we are going to work for the project. The first thing is to find out the total connected load. As I've told you.
One question.
Yes, Mr. Runesh.
Sir, firstly, I will only for building electrical designing or all of things and substation designing is included?
No, we are working with the low tension area, not the high tension area. The secondary side of transformer, whatever we are having from the secondary side of transformer, we are going to work for that area. It can be any project, it can be commercial, it can be residential, it can be domestic. But we are working with the secondary side, I think, but the low tension side, not the high tension side.
Yeah, you will training on for electrical panel designing.
Only distribution boards.
Only
it can be main distribution board, submain distribution board, or your.
But this is a building distribution board, no?
Exactly.
Only for this course is for the building designing, building electrical designing.
Exactly. In building, whatever is needed as for the type of project we are going to propose. For example, okay, you need the MCC panel. You're not going to propose that. You're going to propose the size of machine. By default, the manufacturer will give you the MCC panel.
So you will not learn MCC panel.
we are going to work with MCC, but we are not going to configure the MCC panel. So now you can see, okay, the first thing to work for any project is to find out the total connected load, right? To find out the total connected load. Especially in the European countries or in the Western countries, we are going to work in terms of kVA, and in many of the Asian countries, we are going to work in terms of kilowatts. Anyhow, we can able to convert from kilowatt to kVA, kVA to kilowatt. That is not a big problem. So never get confused between the units kVA as well as the kilowatt. So as electrical engineer,
Sir, this VA is also this is also is equal to watts. So why people wrote like this sometimes kilowatts or kVA? I mean,
exactly.
what is the reason?
Exactly.
Logic.
This I am going to explain you in the chapter.
Because the formula of power is current into voltage, V into I. This
Yes.
is the basics I know a little bit.
Exactly. No. See, basically, Mr. Fahad, okay, we have two different types of power. Just now I've told you that we have the active power and the apparent power. In the active power, we have VI cos phi. In the apparent power, we have VI. Especially the equipments which are going to consume the power, those things are going to be elaborated in terms of kilowatt. And the equipments which are going to provide the supply, those things we are going to, okay, going to be mentioned in terms of kVA. About this brief clarifications we are going to propose in chapter 2 along with some examples.
Okay. Yani there is a logic behind this.
Definitely.
Okay.
Next, talking about single line diagram or one line diagram. So in different countries, the other term called as one line diagram, OLD also. Never get confused with both the things. So what is meant by single line diagram? The schematic flow of power icons. Next, we are going to work with the lighting fixtures. This is a very important area and a very vast area, I can say. Okay, this will take the maximum amount of time when you're going to work for any project. Okay, so here we need the lumen output value from the lamp, we need the lux level, we need the color rendering index values. We're going to work with the maintenance factors, then only we are going to propose a lighting fixture. Okay, so this is the time taking part for any electrical design area. Next, we have the sockets. We have different types of sockets, like we have the normal socket, power socket, industrial socket. Based upon the ampere rating, we are going to classify, and based upon the type of load, we are going to propose this. Next, we are going to provide the supply to the lighting load, to the raw power load, or to any mechanical load by using a transformer. So we are going to propose a transformer based upon the total connected load of the building. This is the main heart, okay, of the complete project. Then again, okay, in case of emergencies, we need a backup. That is nothing but a diesel generator. So we are going to use the diesel generator, especially for the emergency loads. Again, we have the UPS sizing. If you're working with projects or if you're working with corporate offices, like your banks, IT sectors, there we are going to propose the UPS also, uninterruptible power supply. So here, based upon the backup amount of time, we are going to propose the battery. Again, circuit breaker sizing, very important area. Okay, to safeguard the complete system and the design, we need the circuit breaker. So this circuit breaker we are going to calculate based upon the load current value and the safety factors. Again, we have the cable sizing. This is also a very vast and very detailed calculation area. In this, first we are going to understand the type of conductor required. Then again, we are going to select the insulation level. Then again, based upon the manufacturing data, the resistance value, we are going to propose the cable. Once when you propose the cable, again, we are going to justify by using the voltage drop calculation, the short circuit calculation, again, the tripping time calculation. So once when you propose, we are going to work with voltage drop, short circuit, and tripping time. Like for example, I'm going to send some amount of voltage. It is not compulsory that you're going to receive the same amount of voltage. Definitely you'll be finding some drop. Like I'm sending some 230. After 25 meters, you may not get the same 230 because of some internal losses. So we are going to check that. Again, short circuit. Okay, like sometimes what happens, because of insulation failures especially, we are going to get some excess amount of current, which is called as a short circuit. Again, the tripping time. The circuit breaker which we have proposed, we are going to adjust the time also for that. Like I'm having this much amount of fault. So in this amount of time, it has to trip. That also we are going to propose. Next, we have the main background and the main backbone of the design, nothing but called as the load balancing sheet. So here we are going to balance the load equally among all the three phases. Again, we have the capacitor bank sizing to maintain, to enhance, to improve the power factor. Okay. Again, the earthing to provide the safety. We are going to maintain the earth resistance value, and we are going to propose a number of earthing pits. Sometimes we are working with the hilly area or any kind of coastal areas. There is a chance that there can be the lightning strikes on your project. So we are going to propose the lightning arrestor also, okay, which is not required in every project. In the busbar sizing, if we have some enough or more amount of current carrying capacities, instead of going with cables, we go with the busbar ducts or busbar chambers. Again, cable tray, we are going to propose if we have some big size of cables. This is the actual procedure if you're going to work for any project, any MEP area. I hope.
Sir, what is busbar?
Busbar is actually a metallic conductor. Okay, it is made up of a copper. It is made up of aluminium, even the galvanized iron also. Instead of using a cable,
and what is the use application?
To connect multiple cables at one segments.
Okay.
If you want to connect multiple cables at one end, we need a bus bar. You cannot join multiple cables at one side without using a bus bar.
Okay.
I'll be showing you the images and all those.
Excuse me, sir.
Yes.
Will we be learning about electrical panels like EMSB, MCC, the starter panels, the basic ideas of
MCB or MCCB? I didn't get your voice actually.
EMSB, EMCC, and all these kind of panels.
We are going to propose the panels, but we are not going to configure the panels. There is much difference between the proposal as well as the configuration.
Well, I just want to learn about the panels, like how will it work and all these. Like,
definitely.
Okay. And the starter panels, types of starters and all.
Definitely. In the chapter 7, we have that. Next, you can see along with some brief images, I'm going to elaborate the total connected load. Whenever you're working with any projects, I'm not going for the commercial projects. When you're working with small villas or any kind of residential buildings or any commercial projects also, what is the basic loads we have? Nothing but the lights, fans. We are using some electronic gadgets and electrical appliances. So we need the sockets. We have power socket, we have normal socket, and we need the air conditioning. It can be the split or it can be your window. So when you're going to club all these things, we're going to get the total. Same like that if you're going to work for any commercial projects, when you're going to add the mechanical loads, when you're going to add the plumbing and firefighting, that will define the complete total connected load. So based upon that, we are going to propose the single line diagram. You can see this is a small single line diagram where I have got 6 feeders. So in this single line diagram, you can able to understand the complete scope. Like I can say that in this project, I got 1000 kV of transformer, and the feeder 1 is a point of supply. Feeder 2 is a secondary side. Okay, so from here we have got almost like 200 kilowatts of load. To run this 200 kilowatts of load, I have proposed a 300 square mm of cable. Again, here for 70 kilowatts, I have proposed 70 square mm. For 20, I have proposed 6 square mm. Again, for feeder 6, we have got 800 watts. So here I have proposed 2.5 square mm of cable. So in simple words, I can say that by means of single line diagram, we can able to understand the complete outline and the scope of project. Next, talking about the transformer, current transformer and the potential transformer. So already I have told you that we require a transformer, okay, to maintain the frequency as well as to step down the amount of voltage. And to measure the amount of current, we need current transformer. Anyhow, we have the ammeter, multimeter, clamp meter to measure the amount of current, but these devices can able to measure some little amount of current. But if you're having some current capacity, something like 1000 ampere, cannot measure the current with these devices. We need the current transformers and potential transformers. Next, talking about the generators. So in case of emergencies, we are going to use the diesel generators. Again, the UPS and battery. When you're working with commercial projects, especially the corporate offices, definitely we need the UPS. Along with the main supply from transformer, we are going to use one more supply called as UPS or battery supply. Again, the power cable sizing, we have different types of cable. We are going to propose a cable based upon the load, like what type of conductor, the insulation, armor, unarmored, how many number of cores, what type of cable medium, like flat cable, round cable, everything we are going to. Again, talking about the circuit breakers, as I have told you, we have different types of circuit breakers. Again, in these types, we have some classifications, okay, based upon the load, like we have the single pole, double pole or dual pole. We have 3 pole. Again, we have 4 pole, and type of circuit breaker and curves of circuit breaker is also very important. All those things we are going to propose. Next, talking about capacitor bank, enhance or to maintain the power factor, we are going to use a capacitor bank. Next, the earth pit. Okay, so we are going to work with the traditional concept to find out the earth resistance value and to find out the number of earthing pits. Different countries will have some different standards. So based upon that, you are going to work for the earthing. And this is very important area. If you are not satisfying the earthing range, so you will never get the approval for your project. In the bus bar sizing. So you can see, Mr. Fahad, these are the bus bars. So if you want to net some multiple cables, at one point, we are going to use a bus bar. This can be of copper, this can be of your aluminum or even galvanized. Third installation, especially, we have a bus bar. Again, talking about lightning arrestor, if you're working with high-rise buildings or if you're working with projects like petrol stations or if you're having any kind of solar panels, boilers, chillers installed on the top of the roof, in that case, we require the lightning arrestor also for the safety of the building, because all these things may attract lightning, especially in the rainy condition. Yeah, Mr. Fahad.
Sir, can you go back to the bus bar?
Yes, please.
Slide. Right?
Yes.
The picture.
Yes, Mr. Fahad.
Yeah, sir. I can see this one plate. What is the usage of this? There are multiple screws.
Yes. Multiple cables. For example, this is the R phase, Y phase, B phase. That's what. This is the R phase, this is the Y phase, B phase, and this is a neutral for me. So in R phase, for example, I'm going to connect the 6 feeders. So all the 6 feeders will come from here. It will be connected to your bus bar by means of lux.
Sir, what is power factor? You told us in capacitor bank to enhance or maintain a power factor. What is that?
Power factor will define the cosine angle between the voltage and current. We have 3 different types of loads, like we have the resistive load, inductive load, and the capacitive load. The power factor will differ from all these 3. So we are going to see that the voltage and current should follow the same path. There should be no kind of lag nor leak. So that can be achieved with a good resistive load or by connecting the capacitors to maintain the power factor. I'll explain you in the first class, nothing but in the first chapter.
Okay.
Next, talking about cable trays. So basically we have 2 different types of cable trays only. One is a perforated type, one is a ladder type. So based upon the number of cables, based upon the cable area and the width, we are going to propose all these things. Now talking about the course syllabus, so we have 17 chapters in the complete course, and now we have framed the syllabus into 4 segments. Okay, the first segment will cover the basics of electrical engineering, almost like till your chapter 7. From chapter 8, okay, we are going to work with design area. Again, in the segment 3, we are going to work with devices like your transformer, generator, UPS. Again, we are going to propose the cable sizing also. Okay, so and the last segment will be your drafting area. Okay, the last segment. So we have 4 segments in the complete. So the first chapter, as I've told you, we are having the basics. So here we are going to understand about the electrical designing, the basics of electrical engineering, because we have the people from different background. So we are going to work with some simple definitions first, like what is meant by voltage, what is meant by current, okay, what is meant by power factor, different types of loads. All those things we are going to understand in the chapter 1. Again, the types of electricity also is covered in the chapter 1. Next, we have the chapter 2, nothing but the basic formulas. So we are having 3 different types of formulas to find out the current value or to find out the power. Again, for every topic, almost I have the thumb rule calculation also. I have the thumb rule calculation because thumb rule is actually a shortcut method in order to propose a device. And thumb rule is not recommended. Only for the quick results or quick answers, okay, I recommend to go with the thumb rules. That's it. Next, we have chapter 3. This is totally theoretical, where we are going to understand the electrical devices, the codes and standards. So the chapter 3 is totally theoretical. So in this chapter, we are going to understand the electrical equipments, the components, the standards and the codes which we are going to follow, the lux level in order to propose a number of lights, the power consumption in terms of loads, again, how to save electrical energy. All these things we are going to work with chapter 3. Again, chapter 4, we have the illumination design, means which type of lighting fixture we are going to choose for the interior side, for the exterior side, and what type of design we have in the lighting. Again, the air conditioning system also. To maintain properties of air, we require the split AC and the window AC. So that is also very, very important to understand. Again, chapter 5 is the cables. So before going for any new topic, first we are going to work with theoretical part. We are going to understand the parts. Then again, we are going to work with calculation. So first we are going to work with the theoretical part. Again, we are going to work with the calculation part. But this calculation will be only with thumb rule, the shortcut method. In the future classes, we are going to propose with actual formula. Again, chapter 6 will be the circuit breaker. So again,
Sir, in this course, AutoCAD will you train that?
yes, definitely. We are coming for that. The last segment is your drafting, where we are going to use the AutoCAD. Okay, so any version from AutoCAD 2012 or till AutoCAD 2022, you can use. Nothing to worry. So here you can see we are going to understand about circuit breaker, the specifications. Again, we are going to propose a circuit breaker. Next, we have the chapter 7. So here we are going to understand about capacitor bank, the benefits what we have when you're going to install a capacitor bank, and how to propose a capacitor bank, and about electrical machines. So Mr. Anand, as you have asked about the starters and all those things, in this chapter, inshallah, we are going to discuss in the chapter 7. Okay, so this is the first segment of course till here. Now, after this, we have got second segment, where we are going to work with designing calculation. So from here, we have the complete design calculation. So this is the first class. This will be the first class of the design. So in our designing, we are going to use the National Electrical Codes and National Building Codes and Standards. With this, we are going to work with lighting layout, rope-up layout, as well as the air conditioning. And in this also, we are going to cover some basic parts like conversions, because I have seen many engineers who doesn't know how to convert from imperial system to metric system to imperial system. So we are going to cover some basics also regarding the conversions. Again, the load balancing sheet, the backbone of the designing area. Very, very important, I can say. Very, very, very important. To be frank, even I cannot work with load balancing sheet in one single attempt. We have to go with multiple attempts over here, because we need to satisfy the load, we need to satisfy the circuits. Okay, we need to maintain the phase difference also. So all these three cannot be achieved in one single attempt. Okay. Next, we have the transformer. Okay, so here we are going to work with the transformer calculations, again the theoretical parts and the parts of transformer. Next, we have the chapter 10, the same thing. First, we are going to discuss about the generator. Again, we are going to propose the generator. In all these calculations, I'm going to assume some loads with any of my projects. Again, I'm going to propose the device. And next, you can see the chapter 11 will be the UPS. Again, we are going to propose the UPS. Again, to run your UPS based upon the backup amount of time, we are going to propose the battery. Next, in chapter 12, have the cable sizing, the voltage drop calculation. Once when you propose a cable, we are going to justify that cable, because cable constitutes almost like 35% cost of your project. 35% in a rough estimation value, I can say. Like I am going to work with any project. For electrical, for example, I'm getting the total budget of 10 lakh Indian rupee, out of which 3.5 lakh will be only for cable. And majority of the projects will not get approval because of improper sizing of cable only, or majority of the projects will have some serious short circuit issues because of improper sizing of cable. So in order to propose a cable in a proper way, we need to perform the voltage drop calculation. We need to work with short circuit and tripping time. This is a very important and very lengthy calculation. Next, we have the chapter 14. In this chapter 14, we are going to work with four topics. One is the cable tray, earthing, busbar, lightning arrestor. All these four things we are going to work in the chapter 14. Next is chapter 15. So here we are going to cover some basics and the theoretical information about the low current system. The equipments like CCTV public address system, which consumes a current less than 1 or 2 ampere. Okay, those things comes under the low current. Again, the chapter 16 will be your ETAP simulation software. So as the short circuit and the voltage drop and the tripping time is very, very important and a very lengthy calculation. The same calculations we are going to perform by using the ETAP software also, where we are going to first analyze the load. Again, we are going to propose the short circuit values in terms of kiloampere rate. The chapter 17 will be the electrical drafting. So in this electrical drafting, we are going to use the software AutoCAD 2012 is the minimum version recommended, or you can go with any higher version like 2022 also. So in this AutoCAD, we are covering 60 commands, nothing but the basic drawing commands, modify commands, and we are going to learn how to work with electrical agents and how to place all these electrical fixtures also. Next, we are going to use the dialect software 4.13 version to propose a number of lighting fixture. Okay, 2 classes we have for this. Again, the ETAP software, as I have told you, we are going to work with 2 things in this. One is to analyze the load, one is to develop the short circuit values. And in the complete course, we are going to work with 2 projects. One is in the chapter 8, okay, for the residential building, and one after completion of your chapter 8, okay, for your G+6, ground floor plus 6 floors, typical floor plan. Okay, there I'm going to show you the lighting, raw power, air conditioning, control wiring, circuit wiring, load balancing sheet, everything I'm going to. So the softwares, everything I'm going to provide you, nothing to worry about all those things. The same presentation, inshallah, I'll be sharing with you all also. Nothing to worry about all those things. Today, inshallah, we are going to discuss the first chapter. In the first chapter, you can see we are going to cover the basic part, the basic simple definitions, as well as the different types of loads and different types of electricity. The complete first chapter, inshallah, we are going to discuss in today's class. So first thing, whenever you're going to start any new area or whenever you're going to work for a new region, the first thing you have to understand is nothing but the rules and regulation as well as some basics. Then only you can able to understand the complete topic in a very clear way. So chapter 1 you can see is electrical designing. What is meant by electrical designing and the drafting? All these 3 we have discussed in the last class. Now you can see basically whenever you're going to work for any project, the first thing what you have to make a note is we should have a draft plan. We should have a draft plan. How you're going to get a draft plan? With the help of design area. Once the designing is done, then we are going to sketch the same design into the draft model. The same draft model we are going to execute on site. So basically electrical is a module of designing for routing or connecting the electrical and electronic system. Whenever you're going to work for any project, the first thing is to provide the electricity. Okay, you're going to provide the electricity. It can be any type of project. It can be the industry, it can be the plant, or it can be any factory. So we have to provide the reliable supply. If there is no point of supply, you're working with one project, there is no point of supply. So in that case, what you are going to do, you are going to use your own in-house generators, or else you're going to apply for the point of supply from the substation people. But the first thing is to provide the electricity. Next thing, introduction to the building industry. Whenever you're going to work for any project, for example, if the project is very, very big, so designing will be very complex for you. Designing will be very complex. To generate or to develop the complex design, it may take months, even years, and may include number of engineers, supervisors, and technicians. You alone cannot develop the complete model. Okay, you can have a multiple years of experience, but remember that only a teamwork will give you a good result. So make a note that whenever you're going to work for any project, it can be from mechanical area, electrical area, civil, or architect, we have to work in a team. And the team consists of engineers, supervisors, as well as technicians. So you may also have a foreman also. Again, the designing of residential building is much simple. When you're working with small projects, like a residential villa, I can say, so in that case, we need only a few number of people, like 1 or 2 engineers, okay, will look after the complete sector. Like the civil engineer, if he's having ample amount of experience, then he will look after the plumbing also. He will take care of the electrical also. So when you're working with small project, then 1 or 2 engineers are enough. And the designing of electrical system for larger project is responsibility of electrical consultant company. What is meant by consultancy? A group of engineers working in a team. Talking about electrical consultancy. As we are working in electrical area to develop the electrical model, we are working in electrical consultancy company. So this company will work for the development as well as for the execution of the electrical areas. So consultant people may also carry out other duties. Many of the engineers will think that as a design area, it is a white collar job. It's false. Sometimes we have to approach, or we have to develop the bill of quantity also, we have to develop the bill of material also, and sometimes we have to go to the site also for the supervision as well as for the same thing, whether it is going to be carried on site also. So consultant people may also carry out other duties. It's false that being in design, you have to be only in design. Along with this, you have to work for estimation also, you have to work for the installation and execution also. Next, each of the tasks will be performed in coordination with architect. So you are under an architect. Okay, architect is a complete whole and soul responsible person for the complete project. So you will be working under an architect or any senior MEP engineer. You'll be getting a designation as senior MEP engineer if you have minimum 10 to 12 years of experience. That means minimum 3 years of quality experience you should have in every service. Like 3 years in mechanical area, 3 years in the plumbing, as well as the firefighting, again 3 years in electrical. Then you'll be getting designation as senior MEP engineer. So this senior MEP engineer or architect will carry out overall building planning and designing. These are the two people who are going to plan, who are going to design the complete project. The coordination of work is very, very important. Okay, I can simply say that you have to coordinate very accurately between different engineers, but it is not a simple and easy task. So coordination of work between architect and other department is an important as well as very difficult task, I can say. Sometimes because of improper coordination, okay, you have to revise the complete design also. So error in coordination will give you the bad result. So from day one of the project, you have to make a note that whenever you're going to work for any project, we have to provide a good coordination. It may take some amount of time, some revisions, okay, but at last you're going to enjoy the benefit. So better to coordinate from day one of the project. Next, talking about designing of electrical system involves. Whenever you're going to work for any project, we are going to follow some specific chronological order, how we are going to start and how we are going to conclude. So that is what is mentioned over here. The first thing is survey of area. Already we have discussed this in the last class. The people who have joined, okay, today for them, it's light new. So survey of area and type of building or structure. That means whenever you're going to work for a project, you have to see that as per the state electricity board, what are the rules and regulations you are following. Okay, we have different codes, we have different standards. So as per that locality, which local standard is suitable. So as per that local standard only, you're going to develop the complete model. And you have to see type of building also, like whether it is a commercial building or a residential building. Again, nowadays you can see the civil people as well as the architects are going with some different structures. They are going with precast model. They are going with timber. They are going with some iron metal. Okay, so they are using some different structures. So according to the type of structure which they are offering us, based upon that, we are going to develop the model. Again, the total connected load. This is very important thing. If you have got the total connected load for your project, I can say that 70 to 80% of the designing is done. Again, the single line diagram or one line diagram. Once when you have got the TCL value, after which you are going to sketch the single line diagram. So this single line diagram will provide the complete information and the outline of the project. For example, I am very new to the project, but if I know how to read the single line diagram, I can able to understand the complete scope of project, because single line diagram will provide the complete information of project, like from which point, from which area we are going to provide the supply to so and so, different feeders, different cable sizes, equipment sizes, everything is going to be specified in the single line diagram. Next, you can see number of fighting fixture required. This is actually a vast area of calculation in electrical design area to find out number of lamps, because the number of fighting fixtures will be in hundreds when you're working with big projects. So you have to see that how many number of fixtures we are getting, how many number of points we are getting, and all the fixtures are getting the proper supply from proper circuit or not. This is a very important and very vast area of calculation. Again, number of sockets. So sockets, okay, will be very minimum when compared to your lamps. So nothing to worry about this. Again, the circuit breaker sizing. As you can see that to provide a reliable supply and a safe supply, we have to use a circuit breaker. Once when you know how many number of points, how many number of raw points you have, based upon that, we are going to calculate the circuit breaker. Again, the transformer sizing. So once when you are clear with number of lamps, number of sockets, and total connected load, we are going to propose a transformer based upon the total connected load of the building. Again, you can see generator. If you're working with commercial projects, if you have any kind of emergency loads, what are emergency loads? Like your corridor lights, lift, your firefighting pump, water supply machine. These are the emergency loads. So for all these emergency loads, we require a backup. We require a 24/7 supply. For that, we go with the diesel generator. Diesel is actually a fuel, okay, to generate electricity. Again, we are going to use a UPS. If you're working with some MNC based projects, especially the banks or any kind of IT sectors, in that case, we have to provide the UPS supply also. And this UPS will work by means of a battery. Okay, by means of a battery. Again, you can see the cable sizing, voltage drop, short circuit, again the tripping time. These three are 4 important topics in the complete design area. Again, the load balancing sheet or DB schedule for lighting load and drop overload. This is the backbone of the design area. The capacitor bank to maintain the power factor. Remember that the capacitor bank calculation or capacitor bank we don't require in every project. For example, if in your project the mechanical loads are more, like almost like 70% of the load is occupied by mechanical people, in that case we need capacitor bank. What are the mechanical loads we have? Especially the centralized AC, the water supply pumps, the firefighting machines. So all these are nothing but your mechanical loads. So if the consumption of mechanical load is still 70% in your project, in that case, we require a capacitor bank because all the mechanical loads are inductive in nature. To overcome the inductivity and to provide a good quality of supply, we need a capacitor. So in that case, we are going to use a capacitor bank. Earthing calculation, whatever might be the type of project, it can be residential, domestic, commercial, or any kind of hospital or educational building, we have to provide the earthing. If the earthing is not in a proper way, okay, you will never get the approval from the consultancy as well as from the state electricity board. Again, the lightning arrestor to safeguard busbar sizing cable tray. So here is the voltage drop and short circuit. This is a part of designing, but it is not required in every project, because if you are going to work with standard, if you're going to work with rules and regulation, definitely these values will be in the range, because these are the 2 calculations which we are going to perform only to cross verify that whatever the cable we have proposed, okay, is exact or not. That is the reason. So if you are going to work according to the standard, nothing to worry. Okay, if you're going to work according to the standard, no need of cross verification. You'll be at safe side. But if you're going against to standard, what many of them will do, okay, to decrease the cost of project, to work in a very economical way, okay, they will overcome the standards. Okay, so when they are going to overcome the standard, definitely they have to cross verify that whatever the devices they have proposed are suitable or not. So for that point of view, like I have proposed a cable. If I'm going to work with standard, you can ignore these 2 calculations. But if you're not going with the standard, in that case, we are going to cross verify by going with a concept called as voltage drop and short circuit. So this is a complete procedure whenever you're going to work with any project. I hope it's very, very clear till now for everyone. Any doubts? Now you can please clarify. Everyone, please go through. Please go through. In between the class, I'm going to provide you some time so that you can go through and you can able to revise. If you're going to use your running notes also, it's much better. Please go through. The people
Sir,
have
what is short circuit calculation?
Short circuit means excessive amount of current which can enter into the system to damage your equipment. For example, okay, I'm using a device. So this device needs only 10 ampere of current. But because of insulation failure, instead of getting 10 ampere, I may get some 10,000 ampere also. So this may blast my equipment. So I have to check that whether my cable can able to withstand that much amount of fault current, and based upon that fault current, in how much amount of time the circuit breaker has to trip. So this we are going to discuss in the future classes. This is the last part of the design area. Please go through.
Excuse me, why mechanical loads are inductive?
Why mechanical loads? Because by nature they are inductive. By nature, all the machines, because of development of EMF, because of development of the EMF, because of development of the flux, okay, they need some extra amount of current during the initial stage. Okay, so whenever, for example, I have a machine with me, and my machine is having a specification like something like 5 HP is a capacity, and this machine works on 3-phase supply, and this machine is working with an RPM of 2000. So to get a value of 2000 RPM, it takes some amount of time, like something like 10 seconds, 20 seconds, 30 seconds. It depends upon the starter also. So till 30 seconds of time, the machine will take some excess amount of current. So this excess amount of current actually leads to the inductivity in nature. Following on?
Yeah. So you mean all the rotating equipment?
Not only rotating equipments, the equipments which are developing the flux. It can be a rotatory device. It can be any kind of static device also.
Can you mention any machine which is not rotatory?
Machine which is not rotatory, I can say as arc welding machine, spot welding machine.
Okay.
These are inductive in nature. Wherever you have winding, that is inductive in nature.
Okay.
So to overcome this inductivity, we are going to use a capacitor. So whatever the extra amount of current is required to your equipment, that will not be taken from your main supply. It will take the supply from capacitor. Yeah, Mr. Fahd.
Yeah, sir, I want to know actually what is inductive, what you are discussing inductive load.
Yeah, we are coming for that part. Okay.
What is that exactly?
That is a type of load.
Okay.
In technical term, we are calling it as inductive, but in short, you can say that whatever the devices which are having winding inside the equipment, if you have a winding, copper winding, aluminum winding, those are inductive devices. Coming for that.
Okay.
Anyhow, I hope it's clear. So next you can see requirements to perform the electrical designing. I am working as a designer, working into the design team. So I need some input. So what are the inputs do I need to develop an electrical plan? The first thing is nothing but architectural drawing, which will be receiving from the architect itself. So in the architectural drawing, they will specify the complete outline and the scope of project, like where actually they have provided or they have allocated the space to install the transformer, the generator, the earthing pits. Everything is specified in the architectural drawing. Again, we will be getting the civil drawing or the structural drawing. With the help of the civil drawing or structural drawing, we can able to provide the routing for the cables. We are going to propose the distribution boards, the panel boards, everything we are going to propose. Again, the ceiling plan or the false ceiling is also very, very important, because nowadays in every project, it can be residential, commercial, we are having a false ceiling, a dummy type of ceiling, I could say. So in this ceiling, we are providing some electrical fixtures, some mechanical fixtures, and this false ceiling is made up of different types and different shapes. So if you have a proper false ceiling plan in hand, based upon that, you can able to propose a proper light also. Again, the furniture drawing is also very, very important. When you're working with commercial projects, especially, if the furniture drawing is with you, then you can able to provide the sockets position also in a proper way. Like wherever you have a furniture, based upon the type of furniture, you can able to place the sockets as well as the lighting fixtures also. Again, the design brief. Okay, so DBR is actually a type of manual report, I can say, in which you'll be getting the specification from the client as well as the consultant, like which manufacturing company and at what time, okay, we have to develop what plan, okay, what are the coordination results we are getting, everything is specified in the design brief report. So these are the 5 things which we need whenever we are going to work with any project. Without this, you cannot able to work for any electrical plan. You don't require the mechanical, nor the firefighting or the plumbing, but we need these 5 things. If we have the mechanical also, that is well and good. But these are the 5 things which we need before developing or before proposing any electrical plan. I hope it's very clear for it. Next, talking about basics of electrical engineering, BEE. People from the electrical background, for them, I guess this is very, very clear. But the people who are not from electrical, non-electrical people, for them, please concentrate here much, because if you are clear with the starting 3 chapters, then I can say that next chapters will be very, very clear for you, because the starting 3 chapters are totally basics. So first thing, nothing but father of electricity. Okay, many of the engineers doesn't know this. Who is the father of electricity? If you're going to go for an interview, first thing, especially for the beginners or fresher, they may ask you the father of electricity, William Gilbert and Michael Faraday. In some literatures, they have specified William Gilbert. In some literatures, they have specified Michael Faraday. So these are the 2 people who have done the research and development of electricity. So they are called as the father of electricity. Next, talking about electron theory. electron theory. I hope everyone know what is meant by electron. Okay, electron means what? Negative charge particle is called as electron. Negative charge particle is called electron. So now we are talking about a theory. Okay, we are talking about a theory over here. That means a research has been done on electron. So what is that research and who has done that research? So electron theory was discovered in early 19th century. The year as per my knowledge and belief is 1919, but you can say as 19th century by two people, Lawrence and Roth. These are the two people who have done the research on electron theory. So what does this theory mean? What actually this theory has given us? Like you can see here that this is a copper wire. The rectangular thing what you can see is actually a copper wire. So when you are going to keep this copper wire under electronic microscope, so you can able to see the electrons. Here you can see when you are going to keep this copper wire under electronic microscope, you can able to see some electrons. Okay, you can able to see some millions of electrons, and these millions of electrons will be moving in non-uniform direction. Some electrons will go up, some electrons will go down with some non-uniform direction. But to the same copper wire, when you are going to provide some potential difference, nothing but voltage, you can see the plus and the minus sign. You're going to provide the potential difference. So what is happening when you're going to see these electrons are moving in one direction with the speed of light? This electrons are moving in one direction with the speed of light. So that is the research in the electron theory has been done. So it states that when potential difference, what is potential difference? Nothing but voltage. The voltage can also be called as potential difference, is applied to a conductor. The conductor can be aluminum, can be copper, or any metallic part. The electrons which are present in conductor will possess some kinetic energy, means rate of doing work. What is kinetic energy? The rate of doing. And this kinetic energy will start moving in definite direction, means only in one direction with the speed of light. With the speed of light, creating electrical pressure, which is called as current. So this is the research which has been done in the electron theory. I hope it's very, very clear for everyone. Next, talking about voltage. What is meant by voltage? The voltage can also be called as electromotive force, something like EMF, electromotive force. In technical term, we are calling it as electromotive force only. This is actually a quantity or expression that the potential difference or power distribution in charge between two endpoints. So from one point to other point, how much amount of the pressure or the potential difference we are having. So whenever the voltage value is more, the greater the voltage, the greater the flow of electrical current, means flow of electrons will be more. And this flow of electrons will be more in a conductor or in a semiconductor based upon the resistance value. Based upon the resistance value, the flow of electrons will be there. The resistance value is high, the flow of electrons will be less. If the resistance value is less, the flow of electrons will be more. Please make a note of this. Again, talking about voltage, in the symbolic form we are going to write as V, or we can also call it as volts also. Both means the same. Again, this voltage we can able to measure by means of voltmeter, multimeter, potential transformer, or the voltage transformer. This is a different things we have to measure. We have to measure the voltage. We have multimeter, voltmeter. This is the two things which we use. But when you are talking about high tension side, we need the potential transformer or a voltage transformer. Next, talking about current. So just now we have discussed about electron theory. So we are getting some amount of pressure in the electrons now. That is nothing but current. So electrical current is a flow of electrical charges. Which charges? Nothing but negative charges. So in electrical circuit, this charge is often carried by moving electrons in a wire, means flow of electrons. So in simple words, we can say that rate of flow of electrons, how many electrons are flowing. So that is nothing but current for us. So in symbolic form, we are going to write as A, or we can also pronounce as ampere, AMPS. And this current we can able to measure by means of ammeter, clamp meter, multimeter, or current transformer. These are the devices which we are going to use to measure the amount of current. If you are going to measure the amount of current nearby the transformer, in that case we need a current transformer. Again, talking about a conductor. What is meant by conductor? Conductor means it is actually a material which will allow the free flow of electrical current in one or more or multiple directions. The best example is nothing but copper or aluminium, because for the complete house wiring, we go with copper or we go with aluminium. Aluminium is used at transmission side, whereas copper is used for the complete house wiring. Again, we have silver also, galvanized iron, gold, platinum, but we are not going to use for the house wiring. GI, nothing but galvanized iron, we can use for the earthing, for the lightning arresters, but not recommended because the efficiency is very less when compared to copper and aluminium. So in short, I can say that all the metals are nothing but a conductor. So out of all the metals, which metal is giving you 100% efficiency? Platinum. But we cannot go with the platinum for the house wiring. It's very expensive, more than gold. So we are going with copper. Or for the transmission side, we go with aluminium. Next, talking about insulator. Okay, so what is meant by insulator? Totally opposite of conductor. Okay, totally, because the conductor will allow the free flow of electron. This will not allow the free flow of electron. It is totally opposite of conductor. Example, nothing but your paper, rubber, plastic, Teflon, PVC, glass, and wood. These are the things, by which, we cannot able to pass electricity. Even a milliampere of current also we cannot pass with all these different materials. Milliampere of current also. Next, we have one more thing called as semiconductor. We have one more thing called as semiconductor. So what is meant by semiconductor? Nothing but a combination of insulator and conductor. This is actually a man-made device. So this man-made device works as insulator also, works as conductor also. Okay, this is a very important and a very demanding thing in the polytronic area. So semiconductor is a substance. This is actually a substance, usually a solid chemical element. We have the silicon and germanium. Okay, these are the two materials which we are going to use to make a semiconductor, which will conduct electricity under some conditions. So based upon the conditions, we are going to provide the pulses. So whenever we are going to provide a pulse, what is happening? It is acting as a conductor. Whenever we are removing the pulse, it is acting as an insulator. So in short, I can say it is actually a very good medium for the control of electrical current. Okay, you can able to control even milliampere of current also. These semiconductor devices. So in short, whenever current is given, it acts as conductor. Whenever current is not given, it acts as insulator. I hope it's very clear regarding the semiconductor. The best example is in what all your polytronic switches, like we have thyristors, we have transistors, we have SCR, silicon control rectifiers, we have hundreds of polytronic switches. So all those are nothing but your semiconductor devices. So I hope till here it's very clear for everyone. Any doubts? Now you can please clarify. Everyone, please go through.
So, please explain semiconductor.
Semiconductor is actually a type of object or a medium, I can say, which will work as a conductor also, which will work as insulator also. Like combination of this conductor, combination of this insulator. Like you can see, conductor will allow the free flow of electrical current, whereas insulator will not allow the free flow of current, the free flow of electrons. But this is actually a device which works as free flow of electrical current also, which works as free flow of, not allow the free flow of electrons also. Combination of these two things is nothing but semiconductor. Okay, we have IGBTs, we have MOSFETs, we have GTOs. All these are nothing but your semiconductor devices. The name of switches. The name of switches.
Flow of electron or not flow of electron. Semiconductor.
Both thing. When you are going to provide a pulse, it acts as a conductor. When you are not going to provide a pulse, it acts as insulator.
Okay.
It is made up of the germanium and silicon. Now, Mr. Shafiq, please go through. As we are totally into the basic area, okay, we are working with the theoretical part much.
When will this semiconductor act as an insulator? And
it depends upon the microcontroller which we are going to use or which you are going to connect to the semiconductor. Okay, like you have a voltage stabilizer, you have an inverter, or you have any kind of SMPS. So in all these things, you'll be finding a semiconductor. It depends upon the controller, how to control, how to regulate.
So like basically we are controlling the current passing through the...
Exactly. Perfectly. If you want to control some milliampere of current, you want to control a milliampere of current for 0.1 second. This cannot be achieved manually. For this, you need a semiconductor devices. We have different controllers, like we have microcontroller, we have PI controller, we have PID controllers. These are different technologies what we use to use this semiconductor, to connect these semiconductors. now you can see basically in electrical system, the loads are classified into 3 areas. The load is categorized into 3 areas. The first one is nothing but resistive load. Next, we have the inductive load and the capacitive load. So what is meant by resistor? First, understand what is meant by resistor. Resistor means it is an element which opposes the free flow of electrons, which will oppose. So in the last class, we have understood about the current, the electron theory. So there what we have seen, with the flow of electron, we can able to get the value of ampere rating. So here, okay, this flow of electrons are getting opposed because of resistance value. So please make a note that whenever the resistance value is high, the flow of electrons will be less. Whenever the resistance value is less, the flow of electrons will be more. Okay? So take a simple example, a rough example. If you want to go somewhere, okay, it is a distance of almost like 5 kilometers. And to go and to reach to that distance of 5 kilometers, you're having 2 routes. On route 1 is huge traffic, whereas on route 2 there is no traffic. Which one will you prefer? Okay, obviously where you have the least amount of traffic. The path is same, it is of 5 kilometers and 5 kilometers. So same like that, electron will flow in that direction where the resistance is less, where the traffic is less. So here, this resistive load means where the least amount of resistance is there. I'm having an equipment. So in that equipment, if the resistance is very less, that is nothing but resistive load. So how can you able to say this is a resistive load? How can you able to say? With the help of conversion. If the load is taking the input as electrical and giving the output as heat, that is nothing but resistive load. Whatever the equipment, it can be a light, it can be the water heater, it can be incandescent lamp, or it can be anything. So here you can see it is a physical quantity or an element which opposes the free flow of electron, which will oppose the free flow of electron. So resistive loads are typically used to convert current into form of energy such as heat. You can see whatever the resistive loads we have, basically this will change the form of energy. How it will change the form of energy? With respect to your current to heat. So as per the phasor diagram, the voltage and current will be in phase. As per the phasor diagram, the voltage and current will be in phase. What is meant by phasor diagram? Whenever you're going to simulate any model, so before inventing something, what we are going to make a model. Okay, nothing but a simulation model in any software. It can be a MATLAB, it can be anything. Okay, so when you're going to simulate, okay, so what is happening over here? If it is a resistive load, the voltage and current both are starting at 0 degrees and ending at 180 degrees. This is actually one cycle. Okay, this is complete one cycle over here. This is the positive side of cycle and this is the negative side of cycle. So the voltage, this blue color waveform, what you can see is actually a voltage waveform, and this red color waveform, what you can see is actually your current waveform. So voltage and current both are starting at 0 degrees and ending exactly at 180 degrees at pi angle. Again starting at 180, again concluding at 360. So here what we can say, if it is a resistive load, the voltage and current will start at same point and end at same point. So here we are talking about a concept called as power factor. So what is a simple definition of a power factor? The cosine angle between the voltage and current. The angle between the voltage and current waveform. What is the difference we have? And that difference is noted as cos value. So here there is no angle difference between voltage and current, as both are starting at 0 and ending at 360 degrees over here. So here for the resistive load, the cos phi value is 0 degrees. The cos phi value is 0 degrees exactly. And as we know, the cos 0 is 1 as per the trigonometric table. So cos 0 is 1. So here what we can say, for purely resistive load, the cos phi is 1. What is cos phi? Nothing but power factor. So power factor will be 100% if you are going to use a resistive load. There is no kind of loss. There is no kind of loss over here. This is the main concept of your resistive load. I hope it's very clear regarding the resistive load. Everyone, please, any doubts, you can please clarify. Mr. Fahad, it's clear for you?
I want to ask you one question. Pi usually
I'm sorry, Mr. Fahad.
How are you denoting 180 here?
Your voice is not clear, Mr. Fahad.
Yeah, sir. Actually, I want to understand this graph. Yani 0 to pi and pi to 2 pi.
Okay, fine.
Usually
Okay.
pi, sir, the value of pi is 3.14.
Yes, 180 degrees equal to, when you're going to convert, it will be 3.14. But don't convert the value into 3.14. Okay, what is mean by
Sorry?
pi? What is mean by pi in symbolic form? Only 180 degrees. When you are going to
Okay.
convert, that will be 3.14.
Okay. That is symbolic, yani.
Exactly. Okay, never convert the pi value. When you're going to convert the pi, definitely it will be 3.14 only.
Okay. Yeah, okay, got it.
Next here
So,
we can
sir, what about the curve? If the curve is high or low, it does not matter.
we are coming for that. We are coming for the next one. Okay, inductive load.
Okay.
So here you are talking about if the magnitude, okay, this level is called as magnitude. Okay, if the magnitude is more or high, remember that always the voltage will be fixed. Like you can see in your home also, the voltage is 230 for the single phase system. In my home also, the voltage is 230. So magnitude will be fixed. The magnitude for any single phase supply will be fixed. This is a single phase simulated model for the resistive load. So magnitude will be fixed.
Yeah.
Only the current value will differ based upon the load. If you're having a 5 kilowatt of load, the amount of current consumption will be different. If you're having 2 kilowatt of load, the amount of current consumption will be different. So this waveform, this current magnitude waveform will differ, but the voltage will never differ. I hope it's clear for you, Mr. Fahad.
Yeah. It's clear, sir. It's perfectly clear.
Okay, fine. Next, we are going with the inductive load. Now here we are talking about a phase difference value. Here, the phase is 0. Nothing to worry about any kind of power factor value over here. But we have many inductive loads in nature. So basically, what is mean by inductive load? In the last class also roughly I have explained you that whatever the equipment, if it is having any kind of copper winding or aluminum winding, or if it is generating a magnetic energy, nothing but flux, that is nothing but inductive load. It can be anything. It can be a machine, it can be a stabilizer, it can be any SMPS, or it can be anything. If you are finding a copper winding, aluminum winding, or if that equipment is generating any kind of magnetic energy or a flux, that is nothing but inductive load. So it opposes sudden change in current and stores current in the form of magnetic field. So the first sentence itself indicate what it indicates, that this equipment will take some extra amount of current, and this extra amount of current will be converted into the form of energy, nothing but your magnetic energy. Okay, so during this period, the amount of current will be much more. So electromagnetic fields are the key to the inductive loads. The EMF is the main core concept for your inductive loads. So here you can see in the third sentence that with an inductive load, the current waveform is lagging. The current waveform will lag. Why it is lagging? Because during this period, it is taking some extra amount of current. It is storing some extra amount of current to generate magnetic field. So this value, as a rough, I have taken the value of 90 degrees. You can see the voltage will start at 0 with same magnitude, but current is going to be differ. It can be 90, it can be 80, it can be 70. It depends upon the efficiency of your device. If you're working with a good manufacturing company, if you're working with a reliable device, it can be 70 also, it can be 45 also. It depends unless you simulate. Okay, because you can see one equipment is available with a good manufacturing company also, one equipment is available with a bad manufacturing company also. But what is the main difference between these two devices? What is the main difference? You can see the best example is your air conditioner, refrigerator, or whatever the daily home appliances we use. Okay, the power consumption will increase. Okay, in the local manufacturing companies, the lifespan will be less, the reliability will be low. So all this happens when you go with your local manufacturing company. So here the value of your current waveform may differ from one point to other point. So as a rough, only for understanding point of view, I have taken the value of 90 degrees over here. So here you can see the inductive load is a load which pulls large amount of current or inrush current. In the last class also, as I have told you, that any device will take some extra amount of current. Okay, will take some extra amount of current till some amount of time, like till your RPM value reaches. It can be 30 seconds, it can be 45 seconds, it can be for 1 minute also, it depends. So the units of inductive load is nothing but Henry. It is Henry over here. So what is the main concept here we are going to understand? Nothing but power factor. So if you are having the inductive load, what will be the power factor value? So here, what is the difference we have between the voltage and current? Nothing but 90 degrees is the phase difference we have got. So here the power factor value in the symbolic form we are going to write as cos phi. So phi value we have got 90 degrees as per the above waveform. So cos 90 is 0 over here. So for purely inductive load, the power factor will be 0 degrees. I hope it's very clear regarding the inductive load. And the best example for the inductive load is fans, pumps, motors, welding machines, etc. Wherever you find winding, it can be any device.
Can you open the diagram, the phase diagram?
Yes.
Just go back a little bit.
Okay.
I want to understand when the current value is at the peak. Sorry, the voltage value is at the peak. Why the current value is 0?
The current value is not 0. The
But
current
it starts from, it starts.
Yes, exactly.
It starts
Exactly. It starts from 0 only. See, what?
Sir, not this one. Sir, not this one.
Yeah, this one. This one you mean?
One,
yeah, this one.
Load.
Yes. What I have mentioned here in the first, in the first sentence, what I have mentioned, it was a sudden change in current. There will be a sudden change in current waveform because this current is actually being used to generate your magnetic energy. When you generate magnetic energy only, your equipment will work. Getting Mr. Fahad?
Sorry, sir. Please say again. Sorry.
Mr. Fahad, here you can see I am using a machine. Okay, you're having a machine. You're having a machine of 230 volts, something but single phase supply, 1 HP, and this machine works with the speed of 1200 RPM. Okay, so when you're going to switch on your machine, the machine will take some time to reach us your 1200 RPM. Do you agree with this?
Agree.
Something like 30 seconds, 20 seconds, 45 seconds.
Yeah, agree.
So that is this period. That is this period.
Okay.
Okay, that is this period.
Now got it. Thank you.
Yeah. Because when your machine reaches your 200 RPM, then only you can able to deliver something. Like
exactly
supply pump. Okay, you will be getting some discharge amount of value when your machine is rotating at 200 or 1500 RPM. Next, talking about your capacitive load. What is meant by capacitive load? So this is totally reverse of your inductive load. So here what is happening? It suppose a sudden change in voltage and stores energy in the form of current. Okay, it is totally reverse. What was happening in the inductive load? It is supposing sudden change in current. In the capacitive, it is totally reverse. It is opposing sudden change in voltage and stores energy in the form of current. Okay, I hope everyone have seen the capacitors. For every inductive load, you will be finding a capacitor. So what is the reason of capacitor? Okay, nothing but whenever your machine requires some extra amount of current, this capacitor, okay, will provide that extra amount of current. Okay, instead of taking from the main supply. Take one more example, like you are in a room. So in that room, you're having some 2 lights, and from the same circuit, from the 2 lights of circuit, you are connecting a machine also. Okay, the lights are on. So when the lights are on, when you're going to switch on your machine, for a fraction of second, you can able to observe a flicker. For a fraction of second, you'll be getting a blink in the light. What is the reason of that blink? That means this machine is taking the complete current from that circuit for a fraction of second till it reaches the RPM value. So to overcome that flicker, we are going to provide a capacitor. So this capacitor will overcome that flicker. I hope it's very clear. So for every inductive load, we have a capacitor. So this capacitor will store the amount of energy, nothing but current. So whatever the extra amount of current is in that, that will be given by your capacitor. So capacitor load has a current waveform which is reading the voltage waveform. So here it is totally reverse. You can see the voltage and current. The current is already stored in the second quadrant. You can see the current is already stored. This region is nothing but your capacitive region. So whatever the extra amount of current we need, that will be given from your capacitor. So the voltage is starting at 0 only. So as this is the second quadrant, so obviously it will be minus 90. So cos minus 90 will be 0. As a rough example, I'm taking 90 degrees. It can be 45, it can be 60, it can be any value. So example of capacitor load is what? Nothing but capacitor banks and synchronous condensers. So every inductive load will have a capacitor.
Sir, please say again why you put 90, minus 90, negative.
Example, see, this is the first quadrant.
Where is the negative 90?
This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant.
Okay.
So this will be the minus region for you. Okay.
Okay.
The basic trigonometry. Okay. So this is the main concept of your capacitive load. Okay. So one thing I'll be asking for everyone. It's very important interview question also. And especially I hope mechanical people, okay, will enjoy this question and they may also able to answer this. Okay, so my question is, I'm having a machine. It can be a pump, it can be a machine. So I'm keeping a machine in front of you and I'm asking you whether this machine will work with single phase supply or a three-phase supply. I will hide the terminals, the cable terminals. I will hide the nameplate and everything. And my question is whether this machine needs a single phase supply or a three-phase supply. Mechanical people. Getting? I will hide everything.
So usually, we always give single phase supply.
No, I have a 40 HP of water firefighting pump. So 40 HP of machine, how can we go with single phase supply?
Your question is right.
Yeah, did you got my question? See, I have a machine with me.
Okay.
Just by looking at the skeleton or the structure of the machine, you have to say that this is a single phase machine or a three-phase machine. Everyone, please. You can please tell me, Mr. Rizwan, Mr. Anand. By looking at the
220 is one phase. 230 can be three phase.
No. For the three phase, it will be 415. For the three phase. Okay, my question is, I repeat again, by looking at the skeleton or the structure of the machine, you have to say this is a single phase machine or a three phase machine. I will hide the cable terminals. I will hide the nameplate of the machine. How? Especially if you're working as a site engineer or if you're going to work as a site engineer, this can be the interview question. They will take you to the site and they will ask you.
What we have been practicing is, I'm also from mechanical background.
Yeah.
I work with electrical engineers.
Okay.
Our office has a rule that, like, if there is a three-phase available to the site, and if the fan or pump has more than 1 horsepower requirement, then we try and go three-phase just to do like less wiring and everything. So if it is less than 1 horsepower, we try and go with single phase.
Perfect. I agree with you. Okay, till 1.5 HP, we can prefer and we can go with single phase. Above 1.5 HP, we recommend with three-phase supply. Not 1 HP is very minimum amount. Okay, 1.5 also, because some manufacturing companies are offering till 2 HP also for the single phase. But 1.5 is enough.
Yeah.
But I haven't got the answer exactly. Okay, how can you able to say? Okay, like I'll be just showing you one image. With that image, can you able to tell me?
For single phase motor, capacitor will be there.
For single phase motor?
Capacitor is there.
For three phase motor?
Capacitor, it's not required, right?
It's not required. No, I totally agree with you and I really appreciate your answer. But second reference is wrong. For single phase machine, you'll be finding a capacitor. So whenever if a machine is having a capacitor, that means by default we can say it is a single phase.
Single phase.
Okay, you can check your ceiling fan.
Yes.
Take a ceiling fan. It is an inductive machine.
Yes.
By default, the manufacturer will give you the capacitor.
Yes.
We are not going to calculate the size of capacitor. But you can see for all these machines, if it is a three-phase machine, so you'll not find a capacitor. So we as electrical engineer, based upon the type of unit or based upon the type of installation and the power factor value, we are going to calculate the size of capacitor. Getting Mr. Rizwan?
Yes.
Which will be installed into your APFCP panel or into your capacitor bank.
Yes.
So always remember this. So with this, what I can able to justify that every machine needs a capacitor due to this only. Mr. Fahad?
But you know this.
Yeah, sir. But you know, capacitor is always concealed. We don't know yani whether
No,
the
why it is concealed? You can
Because-
see a drum-like structure for every machine.
But sir, in our ceiling fans, it is always concealed.
No,
We cannot see any-
nothing is
no.
concealed.
We
Nothing
can
is
see.
concealed. We can see easily. It's when you're going to assemble your fan, you can able to see. Okay, you can see.
How can we see?
Okay, sir. Now I will check. Now I will
please,
check. Okay,
please.
okay, sure.
Yeah, Mr. Halim.
How can we know that in the pumps is single phase or three phase?
If it is a machine along with a capacitor installed, that is a single phase. If it is a machine without capacitor, it is a three phase. Okay.
Here, where is the capacitor?
Where?
Picture, where is the capacitor?
No. There is no capacitor over here. This is only a starter connection over here. Connections we have over here. You can see.
Can you show a single phase motor with capacitor, similar one?
Okay, fine. I'll just check. My mobile phone, the best image I can say where I have assembled the complete machine. Yeah. Can you see?
Yes.
Okay.
Okay, this is a capacitor.
Yeah, I haven't seen like this at sites, so I was
No.
like confused.
See,
You cannot see like
whenever you're going to work with any project, especially when you're working with commercial projects, that machine will never have a capacitor because those machines will work with three phase only. For
Yeah.
domestic point of view, for single phase machines like 1 HP, 1.5 HP only, you can able to see these things. Following Mr. Fahad?
So, sir,
Drum like
for three phase, let's suppose for three phase pump,
Yeah.
who will size the capacitor yani?
electrical engineer,
On the side
which we are going to discuss in chapter 7.
or a design engineer?
Design engineer. Site engineer will never size anything. Site engineer will only execute, your drawing.
Got it.
Site engineer will never size anything. Okay, he will just execute. Whatever the designing he is getting, the same thing he is going to execute. That's it.
Got it.
Okay.
Got it.
I hope Mr. Rizwan, it's very clear.
Yes.
Yeah, really appreciate.
I mean, I've never
Yes.
seen.
Thank you.
Yeah, Mr. Nihal.
In North America, and
Yeah.
I've never seen this capacitor getting specified. Maybe it's different over here.
If you
Like, I've
have,
never seen a single phase pump. There is no capacitor. Maybe it's just different.
no.
way of manufacturing.
You'll be finding that type of machine and capacitor with your starter box. Check with your starter box.
Okay.
Check with that.
Mhm.
Okay, if it is
sure.
single phase machine, if there is no capacitor attached with your machine, then that capacitor will be in your starter box.
Okay.
Along
the
with your
starter
machine-
box is
Along with
what
your
I
machine, you'll
envision.
be getting a starter box. So check with
Yes.
that. You'll be finding a direct online starter, or if you're working with a good manufacturing company, they will provide you the VFDs. So in that, you can able to find your capacitor.
So actually, if we are using a single phase motor or like three phase motor together, and we have a big system, and we are having a power factor correction equipment at the substation, then we will have a capacitor for the single phase motor alone again.
As per your question that you are working with single phase machine, you are working with three phase machine, but from substation by default, the capacitor is provided to you, but into your project, again, you are having the capacitor. Yes. From the substation side, you'll be finding the synchronous condensers, not capacitor banks. The synchronous condenser is connected at your substation site at high tension site to maintain the power factor value. But at your site, even if you're getting, because the minimum power factor which we are getting from substation is 0.8, nothing but 80%. 20% will be the loss. But if in your project, if the demand of inductive load is more, like 60 to 70% of your loads are inductive in nature. So in that case, you are going to install your own capacitor bank to maintain your power factor and to enhance your power factor, and all those concepts we are going to discuss in chapter 7 in the main calculations. Okay, Mr. Anand?
Okay, thank you.
Because if you are depending upon this power factor value only without installing your own capacitor bank, so what happens? The amount of current consumption will increase unnecessarily, because of which you may expect some more amount of electricity bill and charges. To overcome all those things, we are going to use a capacitor, because by default in this capacitor we have some little amount of energy stored. So whatever that energy which is required in inductive load, that will be provided from your capacitor. Getting, Anand?
Yes, sir.
Next we are going with different
Hello.
voltage. Yes, Mrs. Swati.
सर मुझे एक डाउट है, जब कैपेसिटर करंट स्टोर करता है एनर्जी के फॉर्म, एनर्जी स्टोर करता है तो वो डिस्चार्ज भी होता है, तब हमारी एनर्जी तो लॉस होती है ना, तो इंडक्टर के जैसे तो वो भी तो लॉस में ही चली जाएगी. Are you getting?
Yes, I got your point. Okay, as per your query, what she's asking is, okay, the capacitor is charging and discharging over here. So when it is getting charged, so obviously when we are having, okay, when we are storing some extra amount of current over here, so then again it becomes the inductive load only. I guess Mr. Swati, it's clear. Question आपका ये है?
हाँ, yes sir.
Okay, it's not. See, you are having a battery with you. Okay, so what is the main function of battery? It charges as well as discharges. But after some time, it becomes decay for you. So same happens here also.
Okay.
Okay.
That means,
see, whenever you are changing the form of current from AC to DC or DC to AC, at that point of view, you are getting some losses. But when you're charging or discharging, you will never get any kind of loss. The equipment or that device may get decay. Like after 4 years or 5 years, your battery will not support you like how it was supporting you on the first day. So same happens here for the capacitor. Like if you're using some more amount of current from your capacitor, what happens? The capacitor will burn. You need to replace your capacitor. I hope everyone have seen, especially in the air coolers. Okay.
Window AC also.
Pardon?
The window AC also.
Window AC also. But that becomes slight complex. So best example is air cooler. Following everyone? So whenever you're changing the form of current from AC to DC, DC to AC, at that point of view only, we are getting some losses. But not during this point. Charging and discharging is not a loss. So next you can see the different voltage levels present across the globe. I am not specifying any specific country or specific region or specific standard. This is only the information. Okay, because in some countries for single phase we have some other value, for 3-phase we have some other value. So from where you are getting the confirmation? Okay, you need to check your electricity bill. On that they will provide you the value that single phase supply is so and so, 3-phase supply is so and so, with a power factor of so and so. But as per the electrical distribution systems on international basis, okay, the low voltage, okay, electrical engineers will always work on low voltage value. So what is meant by low voltage? The voltage which lies between 220, 230, 415 and 440 volts. Already we have understood about V, nothing but okay, voltage. So low voltage means what? The equipments which work with the supply of 220, 230. Okay, so 220, 230 will always be the single phase system, whereas 3-phase, 415 and 440. Okay, the electronic engineer or control system engineer or instrumentation engineers, they will work with extra low voltage area. So what is extra low voltage area? The voltage which is generally with less than 200 or 220. That will be the extra low voltage area. Okay, nothing but your shaver sockets, I can say, your trimmer charges, you can say, or your Wi-Fi ports. So all this is nothing but your extra low voltage devices, mobile phone chargers. So that comes under your extra low voltage. As electrical, we are not going to deal with those devices. We are dealing from the low voltage area. So what is mean by normal voltage? The voltage which lies between 3.3 kV. What is mean by K? Nothing but kilo. So 3.3 kV, 6.6 kV, 11 kV, and 13.2 kV. Okay, this is the normal voltage value. Next, we have the high voltage value. The voltage, okay, from 18.2, 22, and 33. All these values comes under the high voltage. Extra high voltage will be 66 and 132. Modern extra high voltage 220, 400, 440. Ultra extra high voltage will be 765 kV. So for distribution side, we always get 220, 230, 415, 440. Whatever the transmission lines or whatever the lines which you are going to see in your localities, in your societies, those will be your single phase or three phase voltage only. But whatever the lines, transmission lines which you can able to see on the highways nearby the junctions, those will be of normal voltage or high voltage. If you are into a metropolitan city, okay, in that case you may also find 33 kV also. But if you are in a normal city, there you can able to find 11 kV also. So this extra high voltage, modern extra high, ultra extra high, all this will be nearby your generating plant where you have the rectifying station, okay, or your inverting stations. There you can able to see all these values. I hope it's very, very clear. And in India, I can say the 90% of the projects will get a supply from 11 kV. So what is the 11 kV as a point of supply over here? Like I'm working with a project. I have a project with me. It is actually a commercial building, I can say, okay, where I have got a lot of 300 kilowatts. So in order to provide a 300 kilowatts of load, I need my own transformer. Okay, I cannot take from the distribution pole. So I have to take from my own transformer. So this transformer will have two ends. One is nothing but the input side. One is nothing but the output side. Every transformer will have two sides. One is the input side of transformer and the output side of transformer. So input side of transformer will always have 11 kV of voltage, especially in India in 90% of the cases. This value may differ in India also, but for some specific reason, which we are going to discuss in the chapter 11 in the transformer calculations. So 11 kV is generally used as point of supply. Okay, in India as well as in many other countries. In the Gulf, we go with 13.8, we go with 22 also, especially in Saudi Arab. Okay, so in India, especially in the state of Maharashtra, we go with 22 kV of point of supply in Maharashtra. Okay, I have no idea why they go with 22 kV, but in Maharashtra, okay, in India we have a state of Maharashtra, there we go with 22 kV. The rest we go with 11 kV only. And these values may differ from one country to other country, but as per electrical distribution system, this is fixed. Values may differ. Next, talking about types of electricity. Okay, so as we are going to deal about electricity in detail, so we have to understand how many different types of electricities we have. So first is something but static, and the next is something but dynamic. The name itself indicates static, means we are having some amount of energy on the surface of the material. Like for example, when you're going to rub your hands, we are getting some energy, nothing but frictional energy or the heat energy, I can say. So whenever if the charges are going to be developed on the surface, that is nothing but static energy. Next, we have the dynamic. So whatever the electricity which we have developed, if we are going to make a category in that based upon the flow of electrons, okay, so that is nothing but dynamic electricity. So here you can see with a simple flow chart, okay, so electricity is classified into natural way, into the artificial way. So what is meant by natural? The name itself indicate, means the energy which we are getting into the natural form, like your lightning strikes or thunder strokes, especially in the bad rainy weather conditions. Artificial means which we are generating, okay, which we are developing, which we are generating. Okay, so this artificial energy we are getting into two forms. One is static, one is dynamic. So what is meant by static? Means the energy which we are generating Okay, it can be from hydro plant, nothing but by using water as a medium, thermal by going with some high grade coal, nuclear by using some chemicals like thorium, plutonium, frictional. We have hundreds of generating plants. Okay, we have hundreds of research papers. You can check your IEEE blog. You'll be finding some hundreds of research papers where we are getting some energy from the frictional process. So the same artificial concept we are going to derive in terms of dynamic, because electricity is classified in terms of alternate current and direct current. So what is the basic difference we have? Okay, many of them doesn't know that which type of energy we have in our homes. Right now you can see you're using your PC, you're using some lights, fans and devices in your home. So which type of energy we are giving? Nothing but AC. So the energy which we are getting, okay, till our distribution board, that will be the alternate current itself. So this alternate current will have a frequency. What is meant by frequency? Number of cycles per second. Just now we have seen the waveform, nothing but the resistive load, inductive load, as well as the capacitive load. So there we have got one waveform. The combination of positive cycle and the negative cycle will give us the one waveform. So this frequency means number of cycles per second. So in India and many of the Asian countries, we have 50 cycles only. Whereas when you go with any kind of European countries or any kind of Western countries, there you can see we'll be finding the frequency of 60. But nowadays, we are having the devices which are working with 50 also, which are working with 60 frequency also, universal. So in this AC, we'll go with the waveform for the better understanding. So here you can see in this AC waveform, you can see we have a positive cycle and we have a negative cycle. Okay, this complete waveform will give you one cycle. Okay, so we have the positive cycle and negative cycle over here. So this, because of this positive and negative cycle, we are having some more losses over here. And this AC transmission is used in small area till 300 kilometers only. If you're going to transmit the supply till 300 kilometers, in that case only we recommend to go with AC line. And in AC supply, we are having three conductors. So these three conductors I am going to denote as R phase, Y phase, B phase. It can be WXY also, it can be 1, 2, 3 also. So RYB I have indicated because R stands for red, Y for the yellow, B for the blue, only as a color codes. When talking about DC, nothing but direct current, the frequency is 0 over here. We have fixed amount of magnitude. Like when you talk about a battery. So battery is having a voltage, a fixed value like 12 volt or your 48 volts or 6 volts. Okay, so here we have a fixed amount of magnitude value. So frequency is totally 0 because here we will never find any kind of positive cycle and a negative cycle. So based upon that, I can say that the losses are less, nothing but minimum to 0, I can say. So this is using long transmission, more than 300 kilometers. Okay. Sometimes what happens, we are going to transmit the supply, okay, from one point to other point, like from one state to other state, one city to other city. The span is more than 300. We go with the direct current line. And here we have only two conductors, positive and the negative conductor, plus and minus conductor. Here we are saving the cost of a conductor also. Following? I hope it's very clear regarding the classification for everyone. Any doubts? Now you can please clarify. Next, talking about power systems. So power system is actually a very vast area in electrical engineering. Almost in 4 semesters, we are going to read about the power system in electrical engineering. Whichever university you are working, if you're studying there, you can see in 4 semesters, we are going to deal with power system. So the first thing in the power system is something about generation. I can say that the combination of generation, transmission, distribution, and utilization is something about power system. So first we are going to generate the power. So we are going to study about this. Again, whatever thing we have generated, that we are going to transmit by means of your AC line, by means of your DC line. Okay. Again, we are going to distribute by your local substations. Again, we are going to utilize. So the study of all these things is nothing but power system. So generating side, the voltage will always be 11 kV. It can be any type of plant. It can be the hydro plant or thermal plant. okay, nuclear plant also, the voltage will be 11 kV. With the help of a step-up transformer, we are going to step up the amount of voltage to 400 or 440. It depends upon the demand. From directly from the generating plant, if the supply is coming to the metropolitan city, the voltage value will be high. If you are going to any kind of remote area, the voltage can be maintained to 33 kV or 66 kV or 132. It depends upon the demand and the load. Again, transmission. So transmission can be done by means of HVAC and HVDC. What is HVAC? High voltage. What is high voltage? If the voltage is more than 33 kV. So here you can see, okay, if the voltage is, up to 33 kV. So 18.2, 22 and 33. So all this value, if the voltage is more than all this value, that is called as high voltage. So high voltage alternate current, we have high voltage direct current. So what this AC and DC indicate? If the span is still 300 kilometer, in that case we go with HVAC. If the span is more than 300, we go with HVDC. Not talking about distribution. So this distribution we are going to do by means of substation. So in every locality, in every area, we can see we have a substation. So based upon that, we are going to get the supply. And as a rough figure, I can say, okay, the tariff, the total expenditure of power system in terms of percentage. Like on monthly basis, we are getting electricity bill now. So on what basis they are charging us? So here you can see the ratio. The generating cost is 40%. The transmission cost is 20. The utilization and distribution charges are 40%. So this is the actual ratio. Based upon this ratio only, they are going to make a tariff. I hope it's very, very clear for everyone regarding the power system. And you can see the flow chart over here. The generation will always be 11 kV. Based upon the demand, we can able to go for 440, okay, or 400, 220, 132, 66, 33, 22, 11 kV. And coming back to the same single phase or three phase supply. Or directly from generation of 11 kV, we can able to get the single phase and three phase. Yeah.
सर अगर वोल्टेज को ये हमने 220 और 440 में ही लाना है तो जनरेशन 11 केवी कर रहे हैं तो फिर हम 66 केवी या 132 केवी फिर ये जनरेट क्यों करते हैं?
कोई जनरेट नहीं करता 66 या 132.
ये 132.
No one will generate 66 or 132 because if you are generating this amount of value, the initial cost setup of the generating plant will increase.
The generating voltage 11 kV.
Obviously, the generating voltage will always be 11 kV or 13.2 or 13.8 kV in the Gulf countries. If you are working with a metropolitan city, like directly from the generating plant, you are going to provide the supply to the metropolitan city. What is metropolitan city? In a city, if you have commercial malls, super specialty hospitals, metro rails, industries, factories. So obviously the demand will be more. The amount of demand of load will be more. So there we cannot go with a small transmission line. So what we do? We are going with some higher amount of voltage value. Mr. Fahad, it's clear for you? Rizwan, Mr. Rizwan.
Yes, yes.
Nehal, Misa.
Yeah, sir. I'm just listening. What is happening? Yeah, sir. Matlab, I have one question. Yani, if you need only 220 volts, then why step up, then step down? Just produce 11 kV and directly distribute. What is the reason?
I'll explain you. I'll come for the simple definition. Here in the last class we have discussed. So here you can see why we are talking about voltage. I hope everyone can able to see. So why we are talking about voltage? The greater the voltage, the greater the flow of electrical current. So when we are having the greater the flow of electrical current, then only we can able to fulfill the demands.
Exactly. Now strike got it. Yeah. This is the perfect answer.
Yeah.
The greater the voltage, the greater the current.
Okay, because your device will need the current, only it will provide you the output.
Exactly, sir.
That is the reason. And one more thing, my previous classes will resemble to my next class. If we are clear with the concepts of the last class, then only my today class will be clear. If we are clear with this 2 and 3 classes, then the 4th class will be clear for you. I have framed my syllabus in such a way that one class will get interrelated with the next class. So each and everything is very, very important over here. Very, very helpful for you also. So never underestimate the theoretical part. Many of them will just overcome the theoretical part. They focus on the calculations. You can only able to understand the calculations when you are clear with this theoretical part.
So this is very important.
Yeah. So this is what we have in the first chapter. So I will not start the second chapter over here. Inshallah, in tomorrow's class, we'll go with the second chapter. So please go with the concepts, what we have discussed, because in next class, we are going with some formulas. We are going with some calculations. Inshallah.
Excuse me, sir.
Yeah.
Will we be learning about transformers, the step up and step down processes?
The sizing of the transformer we are going to do.
Okay, like the theoretically what happens inside the transformer.
Yes, exactly. What parts we have, what actually happens in the transformer, what are the how we are going to assemble the transformer, and how we are going to calculate the size of transformer. All those things we are going to learn in the future classes. But we are working with the low tension side, not the high tension side.
Okay.
Make sure about this.
Okay.
So let us go with the next concept, chapter 2, basic formulae. In this chapter, we are going to discuss about power, very important and the fundamental calculation in the design area. If you are clear with this calculation, then in the future, when you're going to calculate the size of any equipment, that will be very, very easy for you. So basically, in electrical system, the power is classified into 3 areas. In electrical system, the power is classified into 3 areas. So what are the 3 classifications we have? Nothing but active power, apparent power, and the reactive power. So we have 3 different types of power. Now, what is meant by active power? Okay, I need a very simple definition. I don't want to go with any kind of technical definitions, any kind of textbook definitions. I need a very simple definition to understand active power. If anyone can please, I really appreciate what is meant by active power, especially the electrical people.
Active power is useful power.
Can you please elaborate? Because in electrical systems, we cannot say that whatever the power we are generating, it is useful, it is waste. We cannot say in this way. I agree with you. As per your thing, I can able to understand, but everyone have to understand what is meant by active power. Whatever the amount of power which we are consuming is the active power. Whatever the amount of power which we are consuming, like you can see right now, we are using our PC, we are having some lights, fans, etc. things in the room. So all these are nothing but your active power equipments. So this active power can also be called as true power and the real power. In some countries, they call this active power as true power as well as the real power. So you should never get confused. Everything means the same. Please make a note of this. So whatever the amount of power which we are consuming is the active power. Whatever the amount of power which we are consuming is the active power. Okay, whatever.
So just repeat the line.
Whatever the amount of power which we are consuming is active power. Whatever the amount of power which we are consuming is nothing but active power. So how can you able to say that this device is active power device, this device is apparent power device, or this device is reactive power device? By looking at the units, we can say that, okay, by looking at the units, we can say that this is the active power and apparent power. So whenever if the equipment is having the units in terms of watts, in terms of kilowatts, or in terms of megawatts, that will be the active power equipment. If the equipment is having the units in watts, kilowatts, or megawatts, watts, kilowatts, or megawatts, then that is nothing but your active power equipment. So this active power, the loads are classified into 2 types. Active power loads are classified into 2 types. One is nothing but in terms of single phase system. One is nothing but in terms of 3-phase system. Okay, one is in single phase system and one is in 3-phase system. So for 3-phase, the formula will be P equal to, P stands for power, √3 for the 3-phase, V for the voltage, I for the current. We've already discussed about all these parameters in the first chapter. Again, the cos phi value, nothing but the power factor value. This is the basic power factor value which we are getting from substation. And in my course, I'm going with a power factor of 0.8. In my course, I'm going with a power factor of 0.8. If you're working with some metropolitan city, or if you're working with good projects, in that case, a power factor can also be 0.85. Now talking about the single phase system. So for single phase, we have P equal to VI cos phi. There will be no root 3 times. There will be no root 3 over here. And for the single phase, I'm going with a voltage of 230 volts. For three phase, I'm going with 450. In some countries, they go with 405. They go with 440 also for the three phase. For single phase, they can go with 220 also. So these values, you have to check with your state electricity board standards. In many of the Asian countries, they go with this value. And in my complete course, I'm going with this voltage value because in majority of the cases, we have this standard value only. Now the question comes over here. At what point we have to go with three-phase formula? At what point we have to go with single-phase formula? So whenever, if you have a load till 5 kilowatt, in that case, we can go with single-phase supply. That means in my home, whatever the equipments I'm using, so when I'm going to assemble all those loads, if it is not exceeding more than 5 kilowatt of load, in that case, I can go with single phase energy meter or single phase supply to my home. Whereas when you talk about the three phase, if the load is more than 5 kilowatt in your home, okay, or in your flat, so in that case, we are going to take a three-phase supply. We are going to take a three-phase supply over here. Okay, so this is about the single phase and three phase. And in some countries, in some states, we go till 4 kilowatts also. Okay, we go till 4 kilowatts also. And this value will be more than 4 kilowatt over here. In some cases, in some countries. So these two values, again, you have to cross verify from the state electricity board. Now talking about a HP value, because what is meant by HP? Nothing but horsepower. So as we know, 1 HP equal to 746 watts, 746 watts, nothing but 0.74 kilowatts, I can say. So as you can see, the HP is giving you the units of watts or kilowatts. So obviously this parameter also comes under your active power, because whatever the equipments which are having the units of watts, kilowatts, or megawatts, that will be the active power device only. So to achieve this 5 kilowatt of value, we can say that till 6 HP, we can go with single phase. In practical point of view, this is not possible, because if you're going to use a one constant 6 HP of machine, definitely it will be of three phase. But if you are having multiple machines till 6 HP, in that case, we may use. That is also not recommended. But this 6 HP will be less than 5 kilowatt. So based upon this condition, I'm going to say you that, okay, till 6 HP, we can go with single phase supply. I hope regarding the active power, it's very clear for everyone. Next, talking about apparent power. So what is meant by apparent power? The equipments which are giving us the supply, which are giving us the power, those are the apparent power devices. Please make a note of this. The equipments which are giving us a supply or which are feeding us the supply are nothing but apparent power devices. Okay, these are very simple, okay, definitions I can say. The equipments which are giving or which are feeding the supply, those are the apparent power devices. So from where we are getting the supply? From the transformer. From where we are getting the supply? In case of emergencies, from generators. From where we are getting the supply? In case of critical and the sensitive loads, from the UPSs and inverters. So all these are nothing but your apparent power devices. Please make a note of this. The transformer, generator, UPS, inverters, everything are nothing but your apparent power devices, because these are the equipments which are giving us a supply.
Will it include the panels?
Which panels?
Like LT panel, HT panel?
No. Those are the sources. Okay, I mean, those are the mediators from which we get the supply. But no, those are not the devices which are giving us a supply. Those are the mediators. Why we use a panel board? Okay, for the reliable supply to overcome any kind of, okay, short circuits or any kind of faults. Panels are always used to monitor, okay, to troubleshoot, to get a reliable supply for all those things. But we never get a supply from the panel. Transformer, generator, UPS, inverters, battery banks, these are the sources.
Sir, can we say any device which produces power, that is an apparent power?
No, 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 no. We cannot say
Like-
that. No, no, no,
Like
no, no.
generator produces electricity.
See, generator
Electricity.
produces generator produces electricity, but it doesn't mean that that is your that is not your apparent power device. The equipments which are giving us a supply.
But you said equipment which gives supply.
See, what is the other name of generator?
Alternator.
Pardon?
Alternator.
Yes, alternator. Okay, the other name of generator is nothing but alternator. So when you talk about alternator, that is nothing but a device which changes the form of energy from mechanical to electrical. Following, Mr. Fahad?
Yeah, following. But no, I am talking in the light of the sentence. Equipment which gives supply is called apparent power. It means any equipment which produces electricity. We can say like that.
See, what is a basic
question.
why there is a basic requirement of transformer in any project, or why there is a basic requirement of UPS or inverter in any project?
To get the voltage as per your desired, as per the equipment requirement.
Exactly. But this transformer or this UPS,
honestly, I don't know. I just
no.
I just said on the basis of a logic.
No. Basically, you're right. Okay, in a simple way, I can say you that we are going to use a transformer to maintain the voltage value as well as to maintain the frequency and to step up and to step down the voltage. That is a basic definition for the transformer. But remember that this device is actually helping you to get the supply. Getting? Okay, for example, in my project, there's a requirement of 1000 ampere of current. So what is a device which is used to measure this 1000 ampere of current? We cannot go with multimeter, clamp meters. We have to go with current transformers. Following, we have to go with current transformers. So these are actually the sources for us. These are actually the sources for us. I'm talking about the source, not the generating thing. And when you talk about the source, when you talk about the source or when you talk about the supply, we don't have a parameter called as power factor, because in the last class we have discussed about 3 different types of load: the resistive load, capacitive load, and the inductive load. So there we have dealt with a parameter called as power factor, cos phi value, and this cos phi value we have So this cos phi value we are getting based upon the phase difference between the voltage and current. So I am not talking about a load over here. I am talking about a supply over here. So for supply, no need to go with a parameter of cos phi. The formula will be same, like P equal to VI, but there will be no cos phi over here. So for 3-phase, I'm going with the voltage of 415 over here. And for single phase, we go with P equal to VI. And for the apparent power, the parameters or the units will be in terms of VA, kVA or MVA, volt ampere, kilovolt ampere, and the megavolt ampere over here. And all the equipments like transformer, generator, UPS, inverters are measured in these values only. Now here the question comes, till which point we have to go with 3-phase formula. Remember that till 25 kVA, we can go with single phase supply. If the demand is more than 25 kVA, in that case, you have to go with 3-phase connection. So again, these 2 values are given by the state electricity board. In different cities, the values may change. See that in India, we have 27 states, I can say. So in 27 states, okay, out of 27 states, in 25 states, this limit is applicable till 5 kilowatt for the active power. But in a state like Rajasthan, there they have a limit till 7 kilowatts because Rajasthan is not a metropolitan city. So in that case, the department has allocated the value till 7 kilowatt for the single phase system. Whereas in other states, here we have a limit till 5 kilowatt only. But if you're talking about other countries, there they have a limit till 4 kilowatt only. Following? So all these values are cross-verified from the state electricity board people. I hope it's very clear regarding this concept.
This formula is a standard formula under root 3 into voltage into current for 3-phase.
Standard formula in the complete electrical engineering. The formulas will never differ. The formulas which are given by the manufacturer may differ, but these are the literature formulas. This will never differ. Okay, you can opt or you can go for any university across the globe. But the values, but the parameters may change. Like instead of P, some people will go with Q, R. Those things may differ.
Got it.
Okay. They may use A, B, C, W, X, Y. Like I'm going with R phase, Y phase, B phase. They may go with some W, X, Y parameter, U1, U2, U3 parameters. They may go with these parameters, but the basic fundamental will be same. Next, talking about reactive power. Next, talking about the reactive power. So for reactive power, what is a basic simple definition? Remember that the equipments which are used to maintain the quality of power, please make a note of this. The equipments which are used to maintain the quality of power, these are nothing but reactive power devices. The equipments which are used to maintain the quality of power, the equipments which are used to maintain the quality of power, these are the reactive power devices. So in the last class, we have seen that in the inductive load, because of sudden change in current or because of inrush current, there will be a huge demand of current. So to overcome that, we are using a capacitor. So this capacitor will provide a back EMF as well as the inrush current parameter to your inductive load. So this capacitor is actually a power quality tool to your equipment. This capacitor is actually a power quality tool to your equipment. So whatever the equipments which are used to maintain the quality of power, those are the reactive power devices. And here the formula is meant only for the three-phase system, not for the single-phase system. And what is the formula we have? P equal to √3 VI sin phi. So the value is totally reverse. The opposite of cos is sine over here. Why we don't have a formula for the single phase? Because for single phase, by default, the manufacturer is responsible to maintain the quality of power. For three-phase systems, we are responsible. And here I have taken the sin phi as 0.6. Why I have taken the sin phi as 0.6? Because from basic trigonometry, we have a formula under root of 1 minus cos square phi. So what is a cos phi? I'm assuming in my course, nothing but 0.8. So when the cos phi is 0.8, when you're going to substitute in this value, we are getting almost like under root of 0.36, which is 0.6. So whenever the power factor is 0.8, this value will be 0.6. But if in your case, if in your project, if the power factor which you're taking is 0.9, 0.96 or 0.85, in that case, this value may also differ. So based upon the power factor of 0.8, I have got the sin phi value is 0.6 over here. So KVR is used only for the three-phase, so formula remains same for all. I hope it's very clear regarding the three things. Now you can please go through, please revise so that we can go with the next concept.
Actually, how did the value of cos phi become 0.8?
This is the basic power factor which we are getting from substation.
So we took it as reference to change sin phi.
Yes, perfect. You can check your electricity bill or you can check your energy meter. There you will be getting the value like 0.9, 0.8. You can check in your home itself, or on the electricity bill, or at the back side of electricity bill, they will make a print. What is the power factor you're getting from the source of supply?
Well, actually, what is phi?
Phi
Like
is the phase difference. Phase difference.
Phase difference.
Phase difference or angle difference.
Okay.
In the voltage and current.
Okay.
You can write down the basic, the simple definition for power factor, the cosine angle between the voltage and current. Cosine angle. So phi is the angle.
Cosine angle between
voltage and current.
Voltage and current.
So let's go with the next concept, nothing but the examples over here. So solve the following. Okay, find out the current I for all the given loads. I'm having some loads over here. So for all these loads, I have to calculate how much amount of current required to run all these devices. Not specifying any kind of device name, like this is resistive load, this is inductive load or a capacitive load. I'm not specifying all those things. I just need that how much amount of current is required to run this load. I have 500 watts, 3000 kilowatts, 75 kVAR, 12 kVA, 1200 watts, 50 HP, 12 kilowatts, 5 kVAR, 28 kVA, 175 kVA, 5000 watts, 18 HP, 35 HP. So for all these values, I have to find out the current value. Okay, current in the symbolic form is I. Current in the symbolic form is I. So first thing, whenever you have to find out the current value, what you're going to do, you have to check what type of power it is. So here you can see the units 500 watts. Watts means what? Nothing but active power, and less than 5 kilowatts. So single phase system. So formula for the single phase is what? P equal to VI cos phi. P equal to VI cos phi is a formula for the single phase, and for the single phase I'm going with a voltage of 230. So P equal to 500 watts. Okay, nothing but power. Voltage is 230. Power factor which we are getting is 0.8. So I have to find out the I value. So from this equation, to get the I value, I can write as I equal to P by V into cos phi. So P is 500, V is 230, cos phi 0.8. So when you're going to substitute, you're getting the value as 2.71. That means this much amount of current is required to drive your 500 watts of load. Getting? I hope everyone is following this concept. Next, we can see for yes.
So actually, I late because I go to Haram and came. So that's the reason. Can you send me this 20 minutes video?
No problem.
Because actually, yes, thank you very much.
So next you can see for 3000 kilowatts. So kilowatt is what? Nothing but active power. 3000 kilowatt is active power, and more than 5 kilowatt is nothing but 3-phase system. So here we can say this is active power and works on the 3-phase supply. So 3-phase 415 volts. The formula for the active power is what? P equal to root 3 VI cos phi, where P is 3000, V is 415, cos phi equal to 0.8, nothing but the power factor. So we have to find out the I value. So I equal to P by root 3 into V into cos phi. P is nothing but 3000. As a value is in kilo, multiply with 10 power 3 or 1000 divided by root 3, voltage 415, cos phi 0.8, which gives you how much? 5217 ampere. That means this much amount of current requires to drive your 3000 kilowatts of load. Next, we have the 75 kVAR. kVAR is what? Nothing but reactive power. And for reactive power, there is nothing like single phase. Directly, we have to go with 3-phase formula. P equal to root 3 VI sin phi is the formula. So P equal to 75 kVAR, V is 415, sin phi equal to 0.6. Sin phi is 0.6 over here. So here, when you're going to substitute I equal to P by root 3 into V into sin phi, which gives you 173.9 ampere. Next, we have the 125 kVA. kVA is what? Nothing but apparent power. And if it is more than 25 kVA, so obviously it's a 3-phase. So we know that P equal to root 3 VI is the formula for the 3-phase for apparent power. So P is 125, V is 415, I we have to find out. So which gives you 173.9 ampere. Next, for 1200 watts or 1.2 kilowatts also I can say. So watt or kilowatt means nothing but active power, and less than 5 kilowatts of single phase. So P equal to VI cos phi is a formula. P equal to 1200, V is 280, cos phi 0.8, which gives you 6.52 ampere. Again for 50 HP, nothing but active power, more than 6 HP, so 3-phase. As we know, 1 HP is 746 watts. 50 HP means 50 into 746, which gives you 37.3 kilowatts. So again, we have the units in terms of kilowatt. So here also we can say that this is active power only and 3-phase because more than 5 kilowatt. P equal to root 3 VI cos phi is the formula. P is 37.3, V is 415, cos phi 0.8, which gives you 64.86 ampere. 64.86 ampere. Next, we have for 12 kilowatts. Kilowatt is active power more than 5 kilowatts, so 3-phase system. P equal to root 3 VI cos phi. So P is 12 kilowatt, V is 415, cos phi 0.8, which gives you 20.86 ampere. Next, we have the 5 kVAR. kVAR, again the reactive power, nothing single phase over here. So P equal to root 3 VI sin phi. P is 5 kVAR, V is 415, sin phi 0.6. So when you substitute the I value, we are getting 11.59 amp. Next, we have the 28 kVA. kVA means apparent power, more than 25 kVA, so 3-phase system. P equal to root 3 VI is the formula. P is 28 kVA, V is 415, current equal to how much? Which gives you 38.9 ampere. Next, 175 kVA apparent power, more than 25 kVA, so three-phase system. So P equal to root 3VI is the formula. P is 175, V is 415, I equal to how much? Which gives you 243.4 ampere. Next, for the 5000 watts, nothing but 5 kilowatt. Even if you're having 5001 watt also, you have to go with three-phase system. So here we have a limit till 5000. So we know that P equal to VI cos phi is a formula. So P is 5 kilowatt, V is 230, cos phi 0.8. I repeat again, even if you're having 5001 also in that case. So I request everyone to please mute your microphones. Okay. So I equal to much? I equal to P by V into cos phi. So P is 5000, V is 230, cos phi 0.8, which gives you 27.17 ampere. 27.17 ampere. Next, we have the 18 HP. We have the 18 HP. So 18 HP is what? Nothing but more than 6 HP. So directly we can say it's a three-phase system. So 18 into 746, nothing but 13.42 kilowatts. 13.42 kilowatt, more than 5 kilowatts, so three-phase. P equal to root 3 VI cos phi. So P equal to 13.42, V is 415, cos phi 0.8, which gives you 23.3 ampere. Again, you can see the last one, 35 HP. So as we know, 1 HP is 746. If you want to compare, you can see 35 into 746, 26.11 kilowatt. So more than 5 kilowatts, so three-phase, P equal to root 3 VI cos phi. So here we got a current of 45.4 ampere. Here we have got a current of how much? 45.4 ampere. I hope it's very clear regarding this calculation. Any doubts? Now you can please clarify. If everyone.
What is the minimum kVR to change from three-phase to single-phase to three-phase?
What is the minimum? Less than 5 kVAR.
Yes. Like KW, same.
Yes, we can say.
But kVA 25, right?
Yeah, for kVA 25 kVA, because the capacitor size minimum is of 5 kVAR minimum available.
Sir, I would like to ask you one question. What is the importance of knowing the value of current in electronic devices?
Without getting
knowing the value of current in electronic devices. It's a basic question, please.
No. See, without knowing the current value, okay, you cannot run your system itself.
Okay.
Without knowing the current, because if you know that this device required this much amount of current, then only you can able to calculate the size of cable, calculate the size of circuit breaker and all the devices.
Yeah, sir. I have seen in my life, Lani, every electrical equipment requires a different amount of current. Some requires very low current, some requires high current or medium current. So this is what I just want to understand from you, Yani.
I just want to
understand from you, Yani. What is the importance? How we actually? So it helps us in sizing, cable sizing, basically.
Not cable sizing. All the device calculations depends upon the current value only. Like you can see in your home, okay, in your home also you are having the single phase supply. In my home, I'm having the single phase supply. For example, I'm telling you, but the electricity bill to your home is different and my home is different. Can you see?
Yeah. Because of the current value.
Exactly. Okay, see, you can see in your home also you're getting the 230 volts with a power factor of 0.8. In my home also I'm getting the power factor of 0.8 with the voltage of 230. But current consumption is different. Based upon the current consumption only, we are getting the electricity bill. So you can see probably from today itself, I can say you have to work on your assignments. So the assignment for this topic is you have to find out the current for all the given loads. Like I have given for 100 watts, 1000 kilowatts, 55 kVAR, 18 kVA, 2200 watts, 58 HP, 10 kilowatts, 15 kVAR. Again, the 128 kVA, 75 kVA, 4000 watts, 28 HP, 55 HP. For all these, you have to find out the current value and you have to submit me the assignment. And the procedure to work with your assignment is make a separate note or a folder or a file, write everything in a manual way. Never go with any kind of applications or any kind of spreadsheets or Excel sheets. If you work in a manual way only, you can able to memorize all the formulas and you can able to understand when to apply, okay, which type of logic. and use scientific calculator. Don't go for your mobile calculators, because being from the designing department, you should be very hands-free by using your scientific calc. So in your notes also, okay, write everything in a step-by-step manner as mentioned in the notes, the same procedure. If you're writing in one single sentence, it will not give you the, okay, perfection. So I want everyone to please write all these things in your notes. Okay, again, you can scan your page, or you can, okay, capture your page and you can forward me via mail or WhatsApp. No issues with. Next, talking about to find out the power in terms of kilowatts in kVA. Now the concept is totally different, totally reverse. I can say we have to find out the power value in which units, kilowatts and kVA, when I'm having the current value. Like I'm saying with that, I have some 500 ampere of current. So how much amount of load I can put? This concept is totally different. In the previous concept, what was there? We are having some load and we were asked to tell how much amount of current is required to drive that much amount of load. But now the concept is totally reverse. We are having the current and we have to check how much amount of kilowatt and how much amount of kVA we can put. So here the rules are slightly different. So for active power, whenever you're going to work, as we know the active power in terms of watts or kilowatt, till 27 ampere of current, it will be single phase. Above 27 ampere, it will be three phase. Following? Okay, if you're having a current till 27 ampere, it will be a single phase system. If you're having a current more than 27 ampere, it will be a three phase system. For apparent power, as we know, apparent power will be in VA or kVA. Till 18 ampere, we go with single phase. Above 18 ampere, we go with three phase. Following everyone? Now, from where we have got this 27 ampere? From where we have got this 18 ampere? Anyone, please? From where we got this 27 ampere and from where we got this 18 ampere?
This 5 kVR divided by 230.
Yes, yes.
5 kVR divided by
not kVAR, not kVAR, kilowatts. Okay.
Sorry,
yeah, you can see in the above examples. Okay, you can see for 5 kilowatt, how much amount of current we have got? 27 ampere. So we can say whenever we have 27 ampere of current, we can say it's a single phase system. Getting everyone? Now, Mr. Rizwan, again for apparent power, I have given a value till 18 ampere. What is the reason for 18 ampere?
This 25 kiloampere.
25 kVA.
kVA, yes.
No.
kVA divided by 230.
Try. Please try. P equal to VI is the formula. So we have to get the I value. So I equal to P by V. P is 25 into 1000 divided by 230. How much you are getting? I equal to P by V. P is 25 kVA. So 25 into 1000 by 230. How much we are getting?
108.
We are getting how much?
108.
We in the rule, how much it is? 18 ampere only.
18.
So how it is? I can justify. Anyone, please, Mr. Fahad, Anand, Mrs. Swati, Nehal, everyone.
Sir,
as per the formula P equal to VI cos phi, we have got 27 ampere for 5 kilowatt. But P equal to VI also is the same concept we have to apply over here. But when we are applying, we are getting 108 ampere. But as per the condition, it is 18 ampere. See
we
here.
multiply 230 multiplied by 18. So
yes.
Yes.
230 multiply by
18.
18.
Yes.
So
this 4.14 kilowatts.
No. You're going in reverse calculation. Okay, anyhow, see here that what is the basic difference we have between the active power and apparent power formula. In active power, we have cos phi. In apparent power, we don't have the cos phi. So for this 27 ampere, multiply with the power factor value, you will get this value. Getting Mr. Rizwan?
Yes.
27 into 0.8 will be approximately 21 ampere. 21 ampere, but here I've taken how much? 18 ampere, because 2 to 3 ampere will be the stage, or I can say it as efficiency of your device. Because if you talk about apparent power like a transformer, the efficiency will be something like 0.8 or 0.9. So again, when you multiply 21 ampere with 0.8, it will be approximately 18 ampere for you. Getting?
Yes. Sir, but not in apparent power formula, there is not cos phi, no?
Yes, but from this value, if you want to derive this value, you have to multiply with 0.8. Like you can see in coming down with some examples, I'll explain. Coming down with this examples, I'll explain.
Sir, or one more. For reactive power, how can we know from current this is reactive power or not?
I didn't get you.
When you have a current, okay,
Hmm.
then we know up to 27 ampere it is a active power single phase, or 27 ampere reactive power. Sorry, apparent power or active power, but not given here reactive power.
You mean that the for the active power I was mentioned, for the apparent power I mentioned, but for the reactive power I haven't mentioned.
Yes.
Because reactive power is only the device which is maintaining the quality of power. Here, what I'm talking about the power. I'm talking about the load. Okay, I'm talking about the P value. Getting? So here you can see for 800 ampere, as you have specified that here we don't find the any kind of 0.8 in the first calculation itself. I'll explain you here with an example for 800 ampere. Okay, if you want to find out the kilowatt and kVA value, so what is the formula? As we know that it is more than 27 ampere, it is more than 18 ampere. So both the cases are with respect to your three phase only. So if you want to work with watts or kilowatt, the formula is P equal to √3 VI cos phi, because 800 ampere is more than 27 ampere, I is 800, V is 415, cos phi equal to 0.8. So we have to find out the P value. So P equal to √3 VI cos phi is the formula. So P equal to √3, V is 415, I equal to 800, cos phi 0.8, which gives you 460.0 kilowatts. That means whenever you're having 800 ampere of current, you can put 460.0 kilowatts of load. Following next here, you can see for the apparent power. Here again we are working with three phase formula only, because 800 ampere is more than 18 ampere. So I equal to 800, V is 415, P equal to how much? So which gives you 575.0 kVA. Now here you can see, okay, here you can see from this value 460.0 kilowatt, you can develop this value of 575.0, or from this value of 575.0 kVA, you can develop this value. How? Can anyone please tell me? Because from 460.0 kilowatt, I can able to develop the 575 value. How?
Dividing 0.8.
Exactly. When you're going to divide, when you're going to multiply. So here what I am going to do, I am multiplying with this value with power factor to get this value. Mrs. Swati, getting? Here we have got 460.0 kilowatt. When you're dividing with power factor, value, we are getting how much? 575.0 kVA. That means we need this much amount of transformer supply to run your this much amount of load. Getting, Mrs. Swati? So here also we have done the same thing. Okay, we have taken this value and multiplied with the 0.8. Again, I have multiplied with the efficiency value to get the perfect answer. It can be 0.8 or 0.9. Following, Swati? Okay. So here when you divide, or here if you multiply, because here we are missing with one parameter. Which parameter we are missing with? Power factor value, because here we don't have the power factor value. When you multiply with the power factor, you get this value.
Actually, let me clarify. If we are having 575 kVA at the transformer, then we will be getting, we will get usable 460 kilowatt. Is it right?
Yes.
Active power.
Yes. Yes.
Consumable 460 kilowatt.
Perfect. Perfect. Next, talking about 125 ampere. So both are again the three phase for me. Why both are three phase for me? Because more than 27 ampere, more than 18 ampere. Okay, so P equal to √3 VI cos phi. So when you're going to substitute, okay, P equal to √3 into voltage into current into power factor, which gives you 71.88 kilowatts. For apparent power, P equal to √3 VI. So here when you're going to substitute 89.85 kVA. I hope everyone are following the concept. Next, for 168 ampere, again both are three phase. 168 ampere is more than 27 ampere. So when you substitute, we are getting 96.60 kilowatt. If you want to overcome this calculation, what you can able to do, you can able to divide, or if you want to overcome this calculation, you can able to multiply also. It is up to you. The same procedure. Again for 225 ampere. Again, both the cases are for 3-phase only. So 225 ampere is more than 27. So here we have got 129.3 kilowatts. For apparent power, we have got 161.73 kV. Next for 12 ampere. So this is the single phase system. P equal to VI cos phi. P equal to VI cos phi. 12 ampere is less than 27 ampere. So I equal to 12. V, I am substituting 230 because this is single phase system. Many of them working with 3-phase will be habituated to substitute 3-phase value. Power factor is 0.8, P equal to how much? So voltage 230, current is 12 ampere, cos phi 0.8, which gives you 2.20 kilowatts. For apparent power, P equal to VI. So here we have got 2.3 kVA. So the assignment with this topic is you have to find out the load for 500 ampere, 100 ampere, 333 ampere, 10 ampere. So can you able to find out, okay, the reactive power value from this? Anyone? Mrs. Swati? I'm having the 100 ampere of current. Can you please tell me how much amount of reactive power is needed for this? Simple. P equal to root 3 VI sin phi. P equal to root 3 VI sin phi. So we know the I value. I equal to 100 ampere. V is 415. We have to find out the P value. Okay, when you substitute, we get that value also. Okay. For reactive power, never make a concern with single phase systems. We are concerned only for the 3-phase for the reactive power, because by default for the single phase, manufacturer will take care of that. Mr. Fahad following, Mr. Nehad, Mr. Shafiq.
Sir, in the apparent power, why we don't take this cos phi value? What is the reason?
Because the cos phi is taken only at the load side. As if we are having any kind of resistive load, capacity load, or inductive load, at that point only we are going to take the cos phi, because cos phi means what? The cosine angle between the voltage and current, the phase angle between the voltage and current, whether the current and voltage are following the same path or not, as discussed in the last class.
Yeah, cos phi is always taken on the load side.
Yes. So again, the same procedure for you to work with your assignments. Substitute everything in a manual way only. Never go for any kind of applications nor any kind of softwares. Now talking about the thumb rule for the calculation of current. Okay, thumb rule for the calculation of current. I never recommend to go with thumb rule in real time way. Thumb rule is actually used to get or to crack the results in a fraction of a second. That's it. Or to crack your interview also, I can say, because if in the interview, if they ask you that for 5 kilowatt or for 10 kilowatt, how much amount of current needed? So you cannot go with the complete formula P equal to root 3 VI cos phi and substitution. That is a time taking task. So simply you can go with this thumb rules. So here when you're working with secondary side means what? Nothing but the low tension side of transformer you can say, or star side of the transformer you can say, or output side of transformer. Everything means the same. Different people will call it as different way, but everything means the same. So conversion of kilowatt to ampere. So whenever you're going to work for 3-phase, the multiplying factor is nothing but 1.74. I'm talking about active power. When you're working with single phase, the multiplying factor is 5.43. I'll explain you these things with examples. Again for kVA, when you're going to work for 3-phase, the multiplying factor is 1.39. When you're going to work for the single phase, the multiplying factor is 4.32. For kVAR, as we have only one system, 3-phase system, okay, so it is 2.32 for us. Now, if you're working, generally we won't work for the primary side, but if you're working or if you are being asked to check the amount of current at high tension side or delta side or input side of transformer, everything means the same. If you're having a POS of 11 kV, what is POS? Point of supply, source of supply from transformer. In the last class we have discussed, in 90% of cases 11 kV will be the point of supply. I have told you. So if you're having a point of supply of 11 kV, in that case the multiplying factor will be 0.052. If you are having a point of supply of 33 kV, in that case we have a multiplying factor of 0.017. 174. So now, okay, we are going to substitute, okay, a few examples so as to understand these thumb rules in a very clear way. Like I have a 3000 kilowatts of load. Okay, I'm working with the low tension side of transformer. So for 3000 kilowatts of load, go with the formula P equal to root 3 by cos phi, which is very lengthy process. So simply what I'm doing, I'm multiplying with 1.74, I'm getting the current value. So here I'm going to overcome all the formula procedure. You can cross verify by using the formula also, you will be getting the same answer. Again, you can see for 0.5 kilowatt, okay, or 500 watts, you can say. So as it is less than 5 kilowatts, so we go with single phase. For single phase, we have got 5.43 as multiplying factor, which gives you 2.71 ampere. For conversion of kVA to ampere, for 125 kVA, so 125 into 1.39, if it is a three-phase system, which gives you 173.75. Again, for 10 kVA, as this is single phase system, we are getting 43.2 ampere. For kVAR, we have 5 kVAR, for example. So 5 into 2.32, which gives you 11.6 ampere. All these examples, you can able to substitute with your formula also. 99.99% you will be getting the same answer. You can cross verify. So here you are saving your time, but I don't recommend in the real time way to work in this way, because this is not a professional way. If you are working with the high tension side, like I have told you, if you are having a point of supply of 11 kV, the multiplying factor is 0.052. For example, in my project, I have got 500 kV of transformer. Okay, so what will be the amount of current at high tension side? Multiply with 0.052, you'll be getting 26 ampere. If you're having a point of supply of 33 kV, the multiplying factor is 0.0174. I have got a kV of 630. So the current at high tension side will be 10.962 ampere. The same calculations, even if we apply by using the formula, you will be getting the same answers. Okay, so I want everyone, okay, to please memorize all these multiplying factors. And when you're going to work with your assignments, I want everyone to please work with your thumb rules also. When you substitute with your formula, apply with the same with the thumb rule also. Following everyone? Please go through.
Yes.
If any query, you can please clarify. Everyone.
Actually, 26 ampere of current means 26 ampere of current in a second or minute, something like that.
No, we don't. We never resemble in terms of time.
But we have a unit called ampere hours, kilowatt hours for battery.
See, that is when you talk about kWhr for the energy meters, or for your battery banks, we have the AH capacities. That is a separate case. We are not relating the current parameter right now with your hours or seconds or time. You can see. I talk.
Sir, even our mobile batteries, they are also in mAh, milliampere hours.
Yes, definitely. You can see the basic definition of frequency is what? Number of cycles per second. In 1 second, how many cycles you are having? Okay, the positive wave and the negative wave. Okay, so which are nothing but 50 or 60. At present, we are not talking about those values, because when you're going to find out that how much amount of electricity bill you are getting, at that point of view, you need all those parameters. Like when you're going to calculate the battery size based upon the load, I need something like, okay, 30 minutes as backup. So what size of battery I need? That I have to see, that I have to check. Following, like I'm having a load of something like 30 kVA. And for this 30 kVA of load, whenever if there is any kind of interruption from the transformer supply, I need a backup for minimum 30 minutes. So in that case, I have to find out the ampere hour. There the term ampere hour, okay, hour generates. So at that point, I need that parameter. Or if you're working with project, there if they ask you that how much amount of electricity bill you are expecting based upon this current value, at that point we need the HR value. Getting, Mr. Anand?
Yeah, okay.
Yeah, in one of the topic of UPS, I'll be explaining about this in the ampere hour calculation.
So I have a doubt, like suppose if an equipment is 1 ampere or 25 amps, what does it mean?
If the equipment is having a parameter of 25 ampere, what does it mean? That means this device needs this much amount of current, or this device can able to sustain this much amount of current.
Sir, we have multiple devices in our home. Some needs 1 ampere, some needs 25 amperes, some needs 20 amperes, some needs milliamperes. But the source is a constant, 230 volts coming from the
supply,
from the grid station, from our meter,
yes,
from the supply. How these devices, how they are intelligent enough that they take themselves, or what is that
they take themselves with
factor which divides, which gives them, you take 5 ampere, you take 1 ampere. Who distributes?
See, no one distributes.
Okay. Well, sir, please, my questions. I'm sorry, but
see,
to clear my concept,
no, you can see here that, okay, in the first chapter we have discussed about electron theory. When you talk about any conductor, we have electrons. Okay?
Exactly.
When you talk about any conductor, we have electrons in that. So we are not telling the electrons to move here or there. Whenever you are going to provide a potential difference, these electrons will start move. So wherever we have the least amount of resistance value, these electrons will move. For example, in your home, you're having some 5 points, for example.
Okay.
So these 5 points are having some different amount of current requirement. 1 point you have connected with 1 square mm of cable, 1 point you have connected with 2.5 square mm, 1 point you have connected with 4 square mm. So based upon the demand of load, these electrons will start move based upon the resistance value. You're not applying any kind of pressure. You're not telling to go at this side, to go at that side. By default, by nature, they are moving.
Exactly.
That is what the electron theory means.
No, sir. That is okay. But I want to understand how the supply is a constant 220 volts, but one device is taking 10 ampere from the same.
Yes, nothing will happen.
Supply, one device is taking 1 ampere.
Exactly.
Sorry?
Exactly. See, the voltage is 230. First of all, understand the difference between the voltage and current parameter. What is voltage? The potential difference what we have between the two endpoints. And this current is actually a flow of electrons via your voltage medium.
Got it, sir.
Getting Mr. Fahad?
Yeah, sir. I am getting this point, but actually what I want to understand from you is, it's something very small thing, but I hope you can clear my concept. How actually, for example, which is the distribution system that, because the voltage is 230 is going in even in 1 ampere device and in the 20 ampere device. It is something inside the device which actually make sure that we will not get more than 1 ampere. It is inside the device. There is a mechanism.
Exactly. See, for example, I'm using a bulb. Okay, so my bulb needs almost like 0.2 ampere of current. My bulb needs 0.2 ampere. So the manufacturer will make a bulb in such a way that it will consume only 0.2 ampere of current. The driver circuitry, you can say, or the mechanism what they're using, or the technology what they're using.
Okay, sir. Okay.
2 ampere of current, because if it is taking more than 0.2, you'll be having a barrier. It will not allow. Insulation will break.
Now got it. So it means, the manufacturer actually
will make in such a way
different equipments which make sure that this equipment will never get more than the desired current value.
Exactly. Okay.
Answer to make sure that we will not get more than the desired value, we use more resistance, or which electrical components are used for this?
Exactly. When you want to make a barrier, you can increase the resistance value. Like you can take a simple example of your potentiometer. Means what? Nothing but your dimmer or regulator. I can say fan regulator.
Exactly. Yeah. We can
able to vary the value.
Change the RPM of a fan.
Exactly. The same thing. We are making a barrier. The potentiometer is a topic what we have inside that potentiometer. Yeah, Mr. Anand, you were asking something. Suddenly you got disconnected.
Yeah. There was a interruption with the internet. Okay. So actually, I was asking something similar regarding amps. Like, if for example, on lights we can see amps written on the light.
Yes.
So what does it mean? That was my question. Like, how long will it take that particular amps? That was my question, but I think it's clear now.
See, now one more thing you have told me here, that till how much amount of value this will take this much amount of current. Like they have given something like 1 ampere. Always remember that during the initial time, for a fraction of second, the value of current will be high for a fraction of second, because nowadays every light is inductive in nature, not going with any kind of incandescent lamps. Incandescent lamps are totally outdated. The bulbs, okay, which we used to use almost like some 10 to 15 years back. As we are having the LED lights, we are having the CFL and the FL lights. So we have a choke, a ballast, and a driver circuitry. We have some inductivity over here. So initially the amount of current will be high. The manufacturer will not specify the initial current, extra current for the light. Okay, you can take 20% extra of your capacity. Like they have given something like 1 ampere. So take 20% extra of your 1 ampere. Like 1.2 ampere it may take during some amount of time, like for 1 second, for 0.5 second. Then again, it takes, okay, the same value of 1 ampere. Following? In the future, we are going to discuss about all those things in chapter 4, inshallah.
Okay, sir.
Yeah.
Thank you.
Yeah, Mrs. Swati.
Sir, I have a one doubt. When we using thumb rules for calculation of current conversion from kilowatt to ampere, we derive this formula and get 1.74 for three phase, right? By using 1000 divided by root 3 into 230 into 0.8 from 0.052 in primary side and HT side. Can you please derive that formula here?
This is the challenge
So
for you itself. I can say,
I can but I
no,
can't solve this.
no. You have to solve. I know. For example, in your country, you are having a voltage of something like 440. In your state or in your country, for having a voltage of 440, so this multiplying factor is not applicable, because this multiplying factor is applicable only for 415 and 230 volts. But in your country, you're having a voltage of 405, 220 or 440. In that case, what will be the value? Mr. Rizwan getting? Like in Saudi Arabia, we have 13.8 as point of supply, 13.2 as point of supply. So what will be the thumb rule? Because for 11 kV, we got 0.052.
Yes.
But for 13.8, 13.2, what will be the value? Getting, Mr. Swati?
That much, we have to multiply that much.
Pardon?
You have to multiply 13.8 divided by 11. Then we'll get it.
No, try.
Yeah, yes.
You need to try. This is a puzzle.
Yes.
Very important thing. This is actually very, very important and very technical point of view. I really appreciate Mrs. Swati. Okay, but you have to try. Please try. Okay. You can all take one more challenge also. Okay.
Sir, can you revise the question of Miss Swati? What she actually asked?
I'm getting for that only.
0.052 we are getting 1 divided by root 3 divided by 11. It's 0.052.
Okay, for 13.8.
13.8 1 divided by
what was the question actually?
Yeah, I'm coming for you, Mr. Fahad.
0.041.
0.041 for 22 kV.
For 22 kV, yeah?
33
yes.
33 or 22 kV. And 33 is there with us. Okay.
22, yes.
0.026.
0.026.
I'll explain.
Because 22 is a double of 11. For 11.052.
Okay, fine. I agree. Anyhow, okay, Mr. Fahad. Okay, the question is all the multiplying factors which I have given. Okay, like 1.39, 4.32, 5.43, 1.74. These are applicable with a voltage of 230 volts or 415 volts. But if in your city, if you're having a voltage of 220 or if you're having a voltage of 405, 440, then what will be the multiplying factor? Okay, the question is how I have developed this 1.74 value, how I have developed this 5.43 value. So I'm leaving on you, okay, that please try on yourself so that you can able to develop this formula, this value, sorry. Clear with these two chapters, then inshallah next class will be very, very clear for you. The next class is totally theoretical and very important, because here we are going to understand about all the electrical, okay, equipments as well as the components and the codes and standards. The theoretical but very, very Inshallah, today we are going to discuss about chapter 3, abbreviations, in detail, inshallah. So in this chapter, first of all, we are going to understand the equipments, the components, okay, which we are going to size and which we are going to deal in the complete electrical system and the design. So the first thing here you can see is nothing but main distribution board. So what is meant by main distribution board? Whenever you're going to work with any project, it can be residential, it can be commercial, or it can be any type of project, we have to first think that how to distribute the power. So after secondary self transformer, we are having a distribution board. So this distribution board is called as main distribution board. I repeat again, after secondary self transformer, we are having this main distribution board. Some of them, as per the local electricity standards, they call this as energy metering panel board also. Energy metering panel board also, both means the same. Especially in my city, they call it as metering panel. So but internationally, as per the standards, it should be called as main distribution board. So what is mean by main distribution board over here? Remember that from this main distribution board only, we are going to distribute, we are going to provide the supply to the complete building. So in this main distribution board, what we have isolators, we have circuit breakers, we have leakage breakers, nothing but your residual breaker or your earth leakage circuit breakers. These are the things what we have in the main distribution board. How to size all these things we are going to discuss in the future classes. But just right now, think that this MDB stands for the main distribution board. And remember that you have to memorize all these abbreviations. What is the importance if you memorize all these things? Because when you're going to work with any project, especially in the drafting file, you can see you'll be finding only the shortcuts like MDB or any kind of integers. So if you are aware with these integers, if you are aware with these shortcuts, then to analyze and to read the drawing will be very, very easy for you. So you have to memorize all these things. Along with that, you have to understand also what actually this is. Next, you can see something but sub-main distribution board. Again, we are talking about distribution board. So by default, we can say we have circuit breakers, we have isolators, we have main breakers over here. But here from the main distribution board, we are going to get the supply. For example, you are working with big project. So in that project, you are having some 5 departments or 5 stores, you can say, or 5 floors, you can say. So in this 5 departments, you are going to place the sub-main distribution board. In these 5 departments, you are going to place the sub-main distribution board over here. So in this sub-main distribution board, we are again going to provide the supply to the lighting distribution board and the power distribution board. Following everyone, in all these distribution boards, we are going to have the circuit breakers only, the assembly of circuit breaker depending upon the load and the short circuit values. So what is mean by lighting distribution board? What is mean by lighting distribution board? All the light load equipments, please make a note of this, like equipments which consumes the power less than 100 watts or up to 100 watts are placed in lighting distribution board, like your lights and fans. All the equipments which consumes the power up to 100 watts or less than 100 watts, you can say. Those are nothing but the lighting distribution board. So what is power distribution board? Nothing but all the equipments which consumes the power more than 100 watts. All the equipments which consumes the power more than 100 watts. Those equipments we are going to place in the power distribution board. So when you are working with any kind of shopping mall or when you are working with any kind of commercial building, there you can see we have these 2 different distribution board. So the major thing what we have in this is nothing but we are getting a reliable supply, and the maintenance and the troubleshooting will be easy, because if in a distribution board, all the light load, draw power, the mechanical loads, if you're going to place in one board, so what happens if you're getting any kind of maintenance, the complete system will get improper supply or an unbalanced supply, you can say. So to overcome all those things, better if you are going to segregate the lighting points and the raw power points from the distribution side only. Next, we have the FDB, nothing but the fuse distribution board.
Sir, can you repeat again for power distribution board? Consumes power
which consume more than 100 watts.
greater than 100.
fuse distribution board is totally outdated. Now, nowhere in the projects we are going to use the fuse, but if you're going to work with any kind of maintenance projects, if you're working with any kind of old projects, in that case, you can able to see the fuse distribution board. So because of advancement in the circuit breakers, nowadays no one are going with the fuses. Next, we are talking about the AC-DB and DC-DB, nothing but alternating current distribution board and direct current distribution board. So basically, we have two different types of currents. Okay, we have two different types of current. One is alternate, one is direct. So when you're working with industrial areas, there you can see we have some equipments which needs the AC current, which needs the DC current. So from distribution point of view itself, we are going to distribute these things from distribution point of view itself. But this type of concept we can able to find only with industrial products. Next, you can see we have the MPDB, main power distribution board. So this main power distribution board can also be, yes, Mr. Fahd.
Sir, this AC distribution board and this AC distribution board and DC distribution boards, where do we use?
Industrial areas, because in industries we have some equipments which works by AC, which works with DC. Okay.
Got it.
Yeah.
Thank you,
Only
sir.
at industrial areas. Next, we have the MPDB, main power distribution board. So this main power distribution board is almost similar to your main distribution board. For commercial projects, we call it as main distribution board. Whereas when you're working with industrial projects, there we are going to call it as main power distribution board. The concept will be same. Only the terminologies are getting changed over here. Never get confused. Next, you can see we have the ELDB, nothing but emergency lighting distribution board. The name itself indicates emergency loads. So this distribution board will get the supply from two sources. One is from the transformer side, one is from the generator or the UPS or inverter side. So whenever if we have any kind of interruption, by default in fraction of second, we are going to get the supply. So all the common loads, especially common loads means what? Okay, your corridor, parking, okay, whatever the security lights you have, those are nothing but the common lights I can say. So these are getting the supply from two sources. Whenever we have any kind of interruption from one side, automatically we are going to get the supply from other source of supply. It can be generator, UPS, inverters, or batteries. So these are the classifications what we have in the distribution board. I hope it's very, very clear for everyone. Okay, so now as a rough, I'm going to show you some distribution boards where you can able to understand all these things in a very clear way. You can see, as I have told you, in India, especially in my city, this is nothing but main distribution board, but actually this is metering panel board. This is actually the structure, how they are going to cast. They are fabricating. This is the fabricating stage. So in this, you are going to place all your breakers, as well as you can able to place your energy meter also. And the upper side, what you can see is actually a bus bar chamber, from where we are getting all the incoming cables. From the bottom side, we have the main cable. Okay, so at this side, we have the incoming cables over here. This is the fabricating state. So generally, the main distribution boards will not be readily available in the market. We are going to assemble as per the requirements of the project. And this one, you can see a shaft, what they have left is for your, okay, changeover switch. If you are having the generators, okay, if you're having the generators, they are going to provide this. And here, can you see that we are having a larger size of window on this side, but a smaller size of window on this side. Can anyone please tell me what is the reason behind this? We are having a larger size of window over here. The shutter is slight larger, but here it is smaller because here we have the single phase supply. Here we have the three phase supply. So these are the interview questions. Whenever you're going to work at site, they may ask you these type of questions. So this is one of the concept what we have in the main distribution board. Now, when you talk about the distribution boards, okay, so here you can see I'll be showing you a few distribution board. Okay, this is a normal type of distribution board, which you can see inside your building, inside your home, next to your main door, okay, or next to your entrance hall, or nearby to your main entrances, you'll be finding this. So you'll be finding one breaker or an isolator. From this, you're going to provide the supply to the multiple different circuits. So this is one type of distribution boards. We have different concepts in this. So as per the requirements, we are going to use. And you can see this is also one type of distribution board. So in the previous image, what you have seen is connected by means of the bus bars. These are slight expensive, and directly we are getting this type of distribution board from the manufacturing side. So these are slight expensive. So this type of distribution boards we are going to assemble at site as per the load balancing sheet and the schedules. Okay, here you can see we have the main breaker. From main breaker, instead of going with bus bars or any kind of strips, we are using the cables over here. Using the cables. So how to size all those things in the future we are going to discuss. So just I'm showing you the concept, and all this is nothing but breakers. These are the RCDs. This is a 4-pole breaker, and all this is nothing but single pole breaker for us. I hope it's very clear regarding the distribution board for everyone, please.
Can you show the previous picture, sir?
Yes.
Okay, what is the difference between the two? I mean, the name. Is there any?
There is no difference in name with this and this. Some local consultants will go with this. This is also not a local work. This is also a very standard work. But this actually we cannot assemble at site. By default, when you're going to submit your load balancing sheet to your manufacturer, like this is of Legrand make or Snyder make. So they are going to fit, they are going to assemble. So everything will be fitted in a very real-time manner. So here we are going to assemble at site. Almost like 25 to 30% of cost difference will be there. Like this cost you something like 10,000. This may cost you something like 7,000 only. Following?
So
Same breakers will be there. Same breakers will be there. Same configuration will be there. But instead of this bus bar, lux and all those things, we are going to use a cable. That's it. Yes, Mr. Nihal.
If you go back to the previous image. So the bottom one, that's where the main feeds are coming from, and that's the 3-phase. Is that the main breaker for the panel?
Yes, this is the main breaker. This is a 3-pole breaker coming from the sub-main distribution board or the main distribution board or directly from the utility pole.
So sometimes what I have seen is we have 200 amp panel, for example, 3-phase, 208 3-phase. And sometimes the main breaker is sized. It supposed to be sized at 200 amp or more, but sometimes I've seen them sized at 150 amps, and they're just putting 200 amp panel because it's just a standard. Is that normal?
Yes, it's normal. It's normal.
So when we have to look at the amps, the calculated amps, we cannot look at 200 amps. We need to look at 150 amps, correct?
Yes, perfect, right.
Okay.
Sir?
Yes, Mr. Fahad.
You told us in this picture we have a main breaker, then we have isolators. What is the difference between this?
No, I haven't told. From isolator, we are going to the breaker, but from the breakers, we will not go to the isolator.
These are also breakers, Yani?
Everything is breaker over here. Also go with isolator. The basic difference what we have between the isolator and breaker is isolator is a manual device, whereas circuit breaker is mechanically and automatically operated device.
Got it. Okay.
Isolator is manually.
Got it. Thank you.
Next, talking about the MCC, PCC, and PMCC. MCC stands for the Motor Control Center. Okay, when you talk about a commercial project, so there you can see in commercial projects, you are having some different types of machines. Okay, some are dealt with the mechanical department, some are from the firefighting, water supply, different machines we have, and those are huge in number. So instead of connecting a separate drive and monitoring all those things, we have a specific unit called as MCC area or MCC panel, Motor Control Center. So in this MCC, we are going to check the quality of power, the power factor value, and whatever the maintenance are required, those things are monitored from here. So that is nothing but the Power Control Center. Next, we have the PMCC. Nowadays, this MCC, PCC are outdated. Now we are going with PMCC, Power and Motor Control Center, because everything is monitored from one specific area only, the power as well as the motor over here. How we are going to monitor the power? For example, I am working with a project where I have some different requirements. Okay, like in one floor, one story of the building is having a commercial or a bank, or a second floor I have any kind of educational building. Third floor I have something like your go down store or a space. Okay, so same like that I'm having some different demand in different floors. So basically in different places, in different areas, the power requirement is different. So we are going to check that how much amount of power is being consumed or how much amount of power is being allocated in so-and-so store or so-and-so area. So that can be easily achieved by means of PMCC, Power and Motor Control Center. So by default, this comes under the scope of subcontractor by default. Next we talk about, yes, Mr. Fahad.
So sir, it means in our project, yani whatever, how many pumps we have, it will always be connected through MCC panel, all the pumps.
Yes, all the panels. Okay, along with the single line diagram in the future classes, along with in the project class, I'll be explaining you about the connections.
So what? So sir, what if we will not use MCC and if we will use a sub distribution board?
How you are going to distribute the amount?
Is it mandatory?
100%.
Is it mandatory to connect your pumps with MCC panel?
That's what along with the project I'll be explaining you, because one reason I'm going to tell you that what is the requirement of PMCC. Like in PMCC, what we are going to connect? All the machines. So machines will take some extra amount of current, because of which there is a chance that my power factor may dip. My power factor will come down. So I need a power factor correction panel over here, capacitor bank, I can say. So this capacitor bank, if you're going to connect to your MCC, so by default, all the machines which are connected from this MCC are maintained with a value of 0.8 or 0.9 as per the configuration. If there is no PMCC in your project, so for every drive panel or for every starter, you have to connect a separate capacitor bank. This is one of the example. What is the why we need this PMCC? Following?
Yeah.
Okay.
Yes, Mr. Anand.
So in MCC, we have the starter panels, right? The starter, the star delta or whatever starter for each pump we have, all are connected, all are equipped inside the MCC.
Yes.
So if when we make a PMCC, then what type of devices will be added?
We have AVRs, we have ammeters, we have voltage meters. All these things will be there. Like for example, if any of the phase is getting some overt current or any kind of phase is getting any other value as per the requirements, all those things are monitored from here. Next, talking about the ATS panel, automatic transfer switch. The name itself indicates transfer switch, means we are transferring the supply. We are taking a supply from one source to other source. Like for example, I am working with a project where I have two sources of supply. One is from the transformer, one is from the generator. So whenever if I have any kind of interruption from the transformer, I have to get the supply from generator, because in my project there is one more supply which is from generator. So this transfer I have to do in less than a minute, I can say, or in less than 5 seconds. As per the standards, it should be less than 5 seconds. But when you talk about a manual way, it takes something like 2 to 3 minutes minimum. So to overcome this delay of 2 to 3 minutes working in a manual way, I have got a new device which is called as ATS panel. So by default, when we have any kind of interruption from the transformer side, in less than 5 seconds, this ATS panel will send the signal to the generator. So this generator will provide the supply to all your essentials. Again, whenever the supply has been restored into the transformer, this ATS panel will turn off your generator and take the supply from your transformer. So this complete process does in less than 5 seconds as per the IEEE standard. Following? So whenever we have two sources of supply, we need this. Again, talking about APFCP, automatic power factor correction panel, nothing but capacitor banks. Earlier, we used to call it as capacitor banks, but now we are calling it as APFCP panel, automatic power factor correction panel. So what is the basic difference between capacitor bank and APFCP? Like in your home, you are having some different machines. So all these machines, you're not going to use at the same time. Okay, some of the machines you're going to use at peak hours, some of the machines you're going to use whenever there is a requirement. So here, what is happening? The amount of inductive load is not fixed. It's not constant. So whenever there is a requirement, automatically the power factor has to be maintained. So which can be done by means of APFCP, automatic power factor correction panel. Next, we have the circuit breakers like MCB, miniature circuit breaker, MCCB, molded case circuit breaker, ACB, air blast circuit breaker, SF6 sulfur hexafluoride circuit breaker, VCB, vacuum circuit breaker, ELCB, earth leakage circuit breaker, RCCB, residual current circuit breaker, ROCB, residual overcurrent circuit breaker. So these are the different types of circuit breaker. So with this chapter concept, I say that just memorize this abbreviations and full form, because all these concepts in the future we are going to discuss in the circuit breaker calculations. Chapter 6, along with the specifications, okay, along with the theoretical informations and the calculations, there I'm going to explain about all those things. So just memorize the abbreviations over here. Next we have the LBS, nothing but the load breaker switch. So this is actually a highly rated mechanical switch, which you can find especially at the main areas. Like if you're having any kind of, okay, huge size of machines, or if you have any kind of transformers, or if you have any kind of heavy loads, at that point of view, we are going to use this. These are manually operated. Again, we have the high tension switch fuse unit. That means at every high tension side of the transformer, nearby the distribution transformer, we have this panel board, because at high tension side, as we can see, we have 3 phases. So for 3 phases, we have different 3 fuses. It's called as HTSFU. On the road side, you can see this panel. Again, you can see him talking about generator. So generator, basically we have a panel which is called as generator controller panel. So what we have in this generator controller panel, we have the voltage selector switches, ampere selector switches, automatic voltage regulator, auto main failure, breakdown voltage. These are the things what we have in the generator panel. So what is the requirement of voltage selector switch? Basically, generator, okay, is a rotatory device. It's not a static device. So if you're not going to maintain, okay, the generator, so definitely there will be a fluctuation in the voltage. So when you get a fluctuations at voltage side, definitely there will be a fluctuation in the current side. So to overcome that, we are having the automatic voltage regulator, which is actually called as voltage stabilizers. So we have this again, auto main failure and breakdown voltage. If there is any kind of error, so in that case you'll be getting this signal. Means you have to maintain your generator in a proper way, because of heat, because of your excessive RPM value, or because of not putting enough amount of load on generator, also you'll be getting these results. So some manufacturing companies, they have given some range, like whenever you're going to turn on the generator, minimum 25% of the base load you have to put, minimum 25%, to overcome these errors. Next, talking about the BIS, Bureau of Indian Standard. Okay, this is actually a specific standard which is followed in India for energy efficiency. Following everyone, okay, this is actually a standard which is followed in India for energy efficiency. What is meant by energy efficiency? How to save energy, electrical energy I'm talking about. Next, we are having the CEB, Central Electricity Board. Okay, so in every country, we have one department which looks after the complete generation and transmission. So that is, I think, what Central Electricity Board department. Like in India, we have in New Delhi. Again, COS, changeover switch. Like earlier we have discussed about the ATS, automatic transfer switch. So before the invention of ATS, we used to go with changeover switches only. So this is also a type of switch which we are going to use whenever we have 2 sources of supply, but this is manually operated switch, totally manually operated switch. Next, again, you can see we have the CPRI, Central Power Research Institute. Again, we have the CTRC, Central Tariff Regulatory Commission. So this CPRI is actually an institute which works on the research and development of power. Research and development of power, like how we can able to track the energy, how we can save the energy, what is the best resources we can make, how to save the environment. All those things are with respect to your CPRI. Again, CTRC, okay, these are the people who makes a tariff. Okay, like on monthly basis we are getting electricity bill. So who are framing all those charges? These are the people. Again, we have the GI, nothing but galvanized iron. It's a type of metal generally used for the earthing. Okay, generally used for the earthing. Even we have lux also. Again, we have the GLS, nothing but the general lighting services. This is actually a standard, okay, for the lighting people, to find out number of lamps and to place the lighting fixtures. Again, we have the HBC, high breaking capacity and high rapturing capacity fuse. These are the 2 different types of fuses, okay, which you can find in any of the fuse distribution boards. High breaking capacity, high rapturing capacity fuse. These are the 2 different types of fuses. Next, we have the IP, ingress of protection. Every electrical or a mechanical device will have the IP value. So what is meant by IP? This IP will specify the insulation level of the device. Like You can see outside to your home, okay, we're having different electrical and electronic devices. Like we can see we have cameras, we have street lights, we have different electronic we are having different electronic DVRs also nowadays. So all those are exposed to atmosphere. So exposed to atmosphere means what? Is exposed to rain, dust, everything. So if the insulation level is high, so what happens? These things will never harm your device. Insulation level will be maintained. So if the equipment is having the IP value more than 65, please make a note, IP is 65. If on your device, if they have specified something like 65, that means it is totally exposed to atmosphere. We can able to install this device totally exposed to atmosphere. Nothing to worry about the weather, like temperature, rain, dust, moisture, whatever we have.
Sir, usually this IP is specified by number, IP 45, 50,
Yes.
55.
Yes, if it is more than 65,
This 55 represents,
that's what now.
I want to ask you this number 55, what does it represents actually?
It represents the insulation level of your device. Like when you talk about 40, there is very little amount of insulation level. That means it is totally concealed. It has to be totally concealed inside your home. Like when you talk about 50, you can able to place in so-and-so area. If you're going to talk about 60, you can able to place in so-and-so distribution board or any kind of panel board. If you talk about 65 or 67, in that case, this can be installed anywhere as per your requirements. Exposed to atmosphere or any kind of hot place, or it can be anywhere.
Sir, it means we can say higher the number, higher will be the level of insulation.
Perfect. In a simple logical way, you can understand this.
What is the highest IP rating?
Till 80 probably. As per my experience, I have seen till 67, 68 only for solar panel inverters. You can see the solar panels are exposed to atmosphere. So along with solar panel, we have the inverter, okay, which is connected to your solar panel itself. So those boards will have 68, 67 value. As per my experience, I have seen this. But till 80 we have. In the manufacturing data, okay, in any of the catalog, they will specify till 80. Again, talking about OLR, nothing but overload relay. Okay, what is relay? What is mean by relay? Relay is actually a mechanism which is used to sense a fault. Relay is actually a mechanism. Please make a note of this. Relay is only a mechanism which is used to sense a fault or which is used to sense something, not only a fault. Even it can be a signal also, a good signal or a bad signal also. So I'm talking about overload relay. Every equipment or a device like transformer, machine, generators, you'll be finding this overload relay, because if you're going to overload your device, what happens? Okay, it may blow. So to overcome that, we are having this overload relay. So before crossing the limit itself, it will interrupt the supply. Next, we have the ELR, earth leakage relay. So whenever you have any kind of earth leakages, like you are touching your metallic body, like your laptop, or you can talk about your PC. So sometimes we are getting some least amount of current. We'll be getting some jerks. Okay, that is because of improper earthing or because of leakage in supply. So to overcome that, we have this earth leakage relays. Again, LED, light emitting diode, or a type of light. Okay, it's a type of light. Again, we can see we have the MSB, main switchboard. MSB stands for main switchboard, the switchboard which you have in your homes, where we have some different options to connect. You can able to connect, I'll be showing you the image or else. So in this switchboard, you can able to connect anything. You can able to connect your socket of 6 ampere, 10 ampere, 16 ampere, 20 ampere. You can able to connect your switches of 1-way, 2-way. You can able to connect your LAN ports also, your TV port also, even your USB port also, even your bell button or a push button. All those things you can able to put into this lighting switchboard. Following? All those things you can able to place it over here. Next, you can see we're talking about the NGR, okay, neutral ground resistor. This is actually a type of connection done with your transformer side. Neutral ground resistor type of connection you can write or you can remember. Again, OCR, over current relay. Relay, we are talking about relay again, means it's mechanism to overcurrent, to overcome the overcurrent. Okay, to overcome the overcurrents. Sometimes we will be getting some overcurrents. So to overcome that, we have this relay. Again, OLTC, on load tap change. So what is transformer? Basically, basic function to step up or to step down the voltage. So during the on load condition, if you want to step up or step down, in that case, we have this option called as OLTC, on load tap changer. During the on load condition, you can able to step up or you can able to step down. Again, we have the OTI, oil temperature indicator. In transformer, we are having the oil. So this oil is used as cooling medium to maintain the temperature of transformer. So what happens if the temperature of the oil increases? As per the standard, it should be 70 degrees centigrade. If it is going 80, 90, 100, why the temperature will increase? Because if the demand of current is more, in that case, the temperature of oil may increase. So after one instant, what happens? The insulation of the oil will break, and inside the oil, you can expect a fire. Chance that fire may develop. Simple example that talk about your cooking oil when you're going to overheat. So inside your vessel, you'll be getting the flame, you'll be getting the fire. So same happens inside the transformer also. We have to maintain that. Again, we have the RMU, ring main unit. So we have two different types of supply. One is the radial, one is the ring. Okay, ring means what? One device will get the supply from two sources. Whenever any one source will have any kind of interruption, the other source will provide the supply. That is called as RMU, ring main unit. Radial means one device will get the supply from one side only. Again, the SWG, standard wire gauge. Every good manufacturing company will have some specific sizes like 1 square mm, 1.5, 2.5, 4. When you talk about local manufacturing companies, they say it has 2.5 square mm or 4 square mm, but in practical, when you're going to measure, it will not be of the same size. So if you're working with good manufacturing company, you can expect the same size. Again, talking about SWA, steel wired armored. Every cable will have the armor. Every cable will have the armor. Like this is the armor. You see, especially the underground cables will have the armor. But the high tension or the low tension side cables also will have the armor. So this is the armor. So we are talking about steel wire. We have aluminum wire also. We have steel wire also. It depends. Again, WTI, winding temperature indicator. Equipments like machine, generators, transformers will have the winding. So we have to maintain the temperature. Why the temperature of the winding will increase? Because if you're going to use for longer time, if you're going to overload, or if you're going to provide some unbalanced supply, in that case, the temperature of winding may increase. So to overcome that, we're having the WTI indicators. Next, VF, variable voltage, variable frequency. So nowadays for machines, we are having a technology called as VFD. Like we generally used to go with star delta or direct on-light in the olden days. But now we are going to use the VFDs, variable frequency drives. So in this variable frequency drive, we have a technology called as VF, variable voltage, variable frequency. So by varying the voltage and frequency, we are going to get a sine wave, a pure sine wave to overcome the losses. Next, we have the DOF, dropout fuse or burnout fuse or blown out fuse, I can say, if it is damaged. Yes.
So VFD is having VVF, VF?
Yes. VF is technology. VFD is the name of the process, and this is the technology what we use. This is the kind of process to run your machine. Yes. SMFB, shielded maintenance free.
Sir, in this process, VF, how they control the number of cycles?
How we are going to control the number of cycles? By going with some polytronic switches like IGBTs, MOSFET, GTOs. Next, talking about shielded maintenance free battery, nothing but dry battery. Nowadays, you can see to your inverters or your UPSs, we are having the dry battery, just use and throw. These batteries will have a life of 48 months, 56 months. So by default, after this age, you have to again recycle the battery. Again, JB, nothing but junction box. For your PVC conduit accessories, we have this. PB is for the push button, nothing but the call bell button, I can say. Again, TB, terminal box. If you're having multiple conduits going from one point to other point for a longer span, in between, we are having this terminal box so as to pull the cables very easily, as well as to maintain the cables also very easily in the future cases. Terminal box, we call it as. Again, the LCB, local control board or local control station. These are actually the two departments which we have at substation side. So whenever if we have any kind of interruption of supply, these people will get an alert message like so-and-so feeder has been blown out. Again, NONC, normally open, normally close. Every circuit breaker, isolator switch will have this mechanism. Normally open means circuit is open. Normally close, circuit is closed. Circuit is healthy. Again, we have the ACCL, automatic change over current limiter. So this is actually a very new device in the market, which is offered by only one manufacturing company, nothing but Havells. Havells has got this device. So what it is doing is it is limiting the amount of current. For example, I have the interruption from the transformer side in my home. So I have a connection from the generator side also. But if in the generator, if I'm going to put the same amount of load, which I'm going to put from the transformer, so in that case, my generator may get overloaded because generator connection is provided only for the basic loads. So if you are going to put the complete load on the generator, same as transformer, so this ACCL will cut off the supply to overcome the overload on generator. So this is a very new device, ACCL. I'm talking about AC, alternate current or direct current, which we have discussed in the first class. A/C means air conditioning or air condition. There is much difference between AC and A/C. Please make a note, because generally if you're not going to write slash in between, it means that a alternate current. Again, AFL, above flow level or above finish level. Whenever you're going to mount anything like a light or a fan or a junction board or anything, so you should know these values, should know all these values, then only you can able to mark the levels in a very proper way. The marking will be very accurate in all the different areas or different room. Again, CCTV, closed circuit television. For the surveillance point of view, we are using EWE, electric water boiler. On the top of the roof, especially we have this, which is connected by means of solar panels. FL is flow level. For the mounting heights, the architects will provide you this value. FOC, fiber optic cable or your internet cable, I can say. Again, KHZ, MHZ are the units of frequency, kilohertz, mega kilohertz. MS, nothing but mild steel, a type of metal. NTS, not to scale. REV, revision, and WD is nothing but working drawing. These are actually the three things, especially on the drafting sheet we find. If you don't want to scale, or if you are having any kind of errors, you'll be getting the revision mark. Working drawing means approved and finalized drawing. Again, this symbol indicates phase. Again, this symbol indicates conduit, the PVC pipe. CD, candela, the unit of light. dB, decibel, the unit of sound. EF is exhaust fan, which we are going to use in wash areas or utility areas. ELEV, elevators or your escalators also again. Okay, elevators or escalators. Again, ECC, earth continuity conductor. Your earthing cable conductor is called as ECC cable. Like you can see, this is earthing, for example. Yeah, this is earthing for you. These cables are called as ECC cables. EM, nothing but emergency. F for the fuse. FA, fire alarm. KVA, the units of apparent power, kilovolt ampere. Okay, kVAR, the units of reactive power, kilovolt ampere reactive. Watts, kilowatts, megawatts, the unit of active power. HP is for the horsepower. So these are the abbreviations which you have to memorize, which you have to understand. Then only you can able to deal with all these devices when you're going to design. I hope it's very, very clear for everyone. Next, we can see here talking about the codes and standards. So when you're working with any specific area like electrical, mechanical, civil or architect, you are having some specific codes. You have to follow those codes and you have to develop your design model. If you are going to work as per your own experiences without following the codes and standards, you will never get the approval from your consultant nor from your local bodies. So always you have to follow the standards. So here are some of the standards which different people will follow, and you have to be slightly aware with all these standards. I cannot say you have to be perfect in all these standards, but you have to be aware of these standards. Like the first thing here you can see is nothing but NEC, National Electrical Code. So this is actually a specific standard which works on the electrical area, and this is a basic fundamental standard for all the electrical engineers. If you are perfect with this standard, so I can say you that you can able to work with any manufacturing company, or you can able to work with any consultancy across the globe, because this is a basic fundamental standard. From this standard only multiple different standards has been developed. Again, NBC, National Building Code. So this is actually a type of standard followed with all the engineers, like even the mechanical people will extract the data. Electrical, civil, architects, different peoples will take the data from here. Okay, BC. Again, we have the NEIS, National Electrical Installation Standards, whenever you're going to install any device like a generator or a transformer, so you are having some specific bylaws like minimum clearance, how much you have to maintain, what is the resistance value you have to maintain, how much amount of sound level you have to maintain, how much should be the vibration level. Everything is specified in this. Again, NECA, National Electrical Contractors Association. So if you are working with any of the consultant, or if you're working with any of the contractors, then he should have a license from this specific standard, NECA. Again, BS, British standard, followed in the European countries. BEE, Bureau of Energy Efficiency, how to save electrical energy. You can see for all your heavy load devices like air condition, okay, refrigerators, water heaters, you'll be finding the star label like 3-star, 4-star, 5-star. On what basis we are getting this? Based upon the power consumption. So who are providing that? Nothing but the BEE people after cross verifying and after testing and commissioning. Again, IEEE, Institute of Electrical and Electronics Engineering. All the electrical people, the electronic people, they work with this standard, IEEE, especially for the research and development of the complete electrical engineering. Research and development of the complete electrical engineering. Again, IEC, International Electrotechnical Commission. Yes, for testing and commissioning, the QA/QC department people will follow this. IER, Indian Electricity Rules, followed especially in India. ISO, International Standard Organization. Every consultancy or every firm should have a certification, okay, from this ISO. ISI is actually the hallmark. So Indian Standard Institute. So if you're having the hallmark of ISI on any of the device, so blindly you can purchase that device without any kind of hesitation, especially in India. DIVA, SIVA, these are the two standards followed in the Dubai Electrical Water Authority, UAE. SIVA, Sharjah Electrical and Water Authority. In UAE, we have almost like 4 to 5 different standards for electrical people, okay, in different cities. So especially in Dubai, we go with this. In Sharjah, we go with this. Again, NEMA, National Electrical and Manufacturing Association. In India, you can see companies like ECIL, BHEL, okay, so HCL. These people work with your NEMA, National Electrical and Manufacturing Association. Again, NFPA, National Fire and Protection Association. All the firefighting people, okay, will follow this rule. Again, the FSA also the same thing, Fire Security Association of India, but this is specific with specific local body, India. Again, IPC, Indian Plumbing Code, followed with the Public Health Engineer or your plumbing engineer. ASHRAE, ISHRAE are the two standards, followed by the mechanical engineer for the HVAC systems. ASHRAE stands for the American Society of Heating, Refrigeration, Air Conditioning Engineers. ISHRAE stands for the Indian Society of Heating, Refrigeration, Air Conditioning Engineers. Whereas NIBOSH, ISOSH, OSHA, these are actually the 3 standards followed with, or the certifications I can say, followed with your safety engineer. You can see for every multinational company, if you're working with a good consultants, you can see you'll be finding the safety engineers. So those people will get this designation as safety engineers if you're having the certification from NIBOSH, ISOSH, OSHA. The 3 certification. I hope it's very, very clear regarding this. Next, you can see actually we have the lux level. What is meant by lux? Lux is actually the amount of brightness required in the room. Like you can see, I am in a classroom. So in my classroom, I need some specific amount of brightness so as to work, so as to deliver. So here I need minimum 300 amount of lux. Minimum, I mean to say. So if you're having minimum 300 amount of lux, then the presentation will be good. Then you'll be getting the interest to work, as well as you'll be not getting any kind of flicker also in the eye. So these are the things. Whenever if you have a good quality of brightness in the room. So as per the national building codes and standards, they have given some specific lux values. Okay, so these lux values we are going to use in the future classes. Okay, when we are going to work with lighting calculations in the chapter 8. So LX is a symbolic form for the lux. LX is a symbolic form for the lux. Like when you're working with any project, I'm not specifying the project name, you'll be finding the corridor, passageway. In that case, you should have the 100 amount of lux. Means 100 is the amount of brightness. So to achieve this 100, as per the room geometry, based upon the lumen output of the lamp, how many number of lamps or how many number of fixtures we need. That we are going to check. Again, the lift 150, staircase 150, escalators 150. Like I'll be showing you one of the lux meter. You can see this is actually the lux meter. It's almost like your multimeter device, okay, which comes into your palm very easily. So this will give you the amount of lux, how much amount of brightness you have. So once, okay, you have installed all your fixtures, so your QA/QC people or your testing people will come and they are going to check the amount of lux is getting satisfied or not from your artificial light sources only. So based upon this lux values only, you are going to calculate the number of lamps and lighting fixtures. So these topics are actually the this is actually the reference topic when we go with the future calculations in the chapter 8. So right now, for instance, please go with all this value. Remember that higher the lux value, more will be the amount of brightness. Like you can see here, I have given the 1000 amount of lux for a fine work. Fine work means what? When you're going to work, when you're going to carve anything, when you're going to work in a very detailed manner, there if the amount of light is more, then you can able to work very clearly. Like especially the goldsmith, when he is going to make an ornament, so you can see that exactly on the top of the table, nearby to his hand, he'll be finding a lamp. Why? Because he is going to work very precisely. The same thing for the wooden carpenters also. Okay, when they are going to make any kind of carvings, when you're going to make any kind of designs, they are going to work in a broad daylight with some more amount of brightness. So all those values are specified over here. So I want you all to please go with this 4 pages right now in the class so that you'll be getting the overall outline knowledge. This concept is very, very helpful for you and very, very important for you when you're going to work with the calculation to find out number of lamps. So please go through. Next, you can see we are going with the next topic, nothing but the load details of different appliances which are used in day-to-day life. Remember that whenever we are going to work for any project, the first thing is to consider the total connected load of that building or the plant. So how are you going to extract the total connected load? You know the specification of that device or appliance, then only you can able to find out the complete load of that area. So here I'm not specifying any manufacturer name or any kind of capacity nor any kind of standard. Whenever you're going to work for any appliance, it will consume some minimum amount of load to the maximum amount of load based upon the operation, how you're going to perform. So now let's talk about washing machine. So whenever you're working with any kind of residential projects or any kind of domestic projects, there you can see there will be a requirement of a washing machine. So there the washing machine will consume minimum 400 watts to maximum 2000 watts. Minimum is 400, maximum is till 2000 watts, I can say. As washing machine is a variable load, I cannot say that it will always take 1 kilowatt, it will always take 0.5 kilowatt. We have different modes of operation. So based upon the mode of operation or the load what you are going to put, it will take the power from you. Next, we have the water heater, the geysers, I can say. So that is from 800 watts to 3200 watts. Microwave oven, 800 to 3200. Even the range oven will take the same capacity. When you talk about commercial projects, there the wattage or the load may differ. But here we are talking with domestic point of view. Iron box to press your clothes. Here you can see 400 to 1600. Dishwasher, okay, to wash your utensils in kitchen. That will be from 400 to 1600. As you can see, almost in every project nowadays, okay, it is almost important to have the dishwasher. So this also we have to consider whenever you're going to work for any new project. Freezer or refrigerator, 600 to 1200. When you talk about the outdated refrigerator, almost which we used to have in 1990s, I'm not talking about that capacity. I'm talking about the capacity of those equipments which are certified from BEE standard, Bureau of Energy Efficiency standard, because all the equipments which are having the star label will take the minimum or the least amount of electrical energy. Next, you can see we have the mixer or grinder, 400 to 1200 watts, or more than this also you can. Rice cooker, 400 to 3200. Vacuum cleaner, 600 to 1400. Ceiling fan, 40 to 100. Water filter, which we have in the kitchen. So nothing but 100 to 600 watts. Exhaust fan, which we are using in the kitchen, in the bathroom, in the wash areas, retreat areas, that will be from 60 to 250. Chimney kitchen, 400 to 600. Air cooler, 250 to 750. Milk systems or home theaters, 200 to 700, or more than this is also available. TV or monitor. I'm talking about the cathode ray tube. You go with any other concept like LCD, LED, that is having a different specification. But if you're having the CRT monitor or a TV, it will take 80 to 160 watts. Again, we have the LCD, 80 to 120. We have LED, 40 to 100 watts over here. So I repeat again, here I'm not specifying any manufacturing company name nor any kind of capacity. These are the approximate values. And whenever you're going to work for any residential project or any domestic project, all these requirements has to be fulfilled. Even if the client is not providing you the number of points, but you have to train him and you have to offer all these points, because almost in every project there is a requirement of all these points. Please make a note of all these things. When you are going to assemble all these things, then only you are going to get the value called as total connected load. So when you have got the total connected load value, then only you can able to calculate the size of main cables, distribution boards, you can balance the load, multiple things you can able to do once you have the total connected load of the building. I hope it's very, very clear. When you're working with any kind of commercial projects, there if you have any kind of three-phase loads, so you have to check from your manufacturer, or you can check the specifications or the nameplate of that device. It is up to you. Next, you can see we are going to understand how to save electrical energy, because many of us doesn't know how to minimize the consumption of electrical energy. As you can see, almost across the globe, because of different change in environment conditions, because of global warming, I can say there is a much difference in change in environment. Okay, even in summer season, you can see we are getting rain. Even in winter season, you can see the temperature is almost more than 30 degrees centigrade. So why this is happening? Because of change in environment condition. So why there is a change in environment condition? Because of burning of fossil fuels, in short, I can say. So to save the environment, we have to minimize the consumption of electrical energy. So the first major thing to minimize the consumption of electrical energy is to use the renewable energy sources like solar, or you can talk about wind, or combination of solar or wind, or we have different sources also for renewable energy sources. But as per the lead examination, lead is actually a standard, okay, or an examination you can say, which is actually opted by architects to save environment. So from that certification or from that standard, I have taken few points, because being from electrical department, you have to be very, very efficient how to minimize the consumption of electrical energy. So here roughly I'm going to explain about the complete topic. Whenever you're going to work with any project, or in your home also, you can see that we are having numerous number of electrical and electronic equipments: TV, refrigerator, washing machine, MP3 player, music system, computers, laptops, and more than this only. But no one is not going beyond the limit of this. Everyone are crossing the limit. So usage of these equipments is not restricted. We can use, but we should have proper knowledge to use all these appliances. Because of improper knowledge or lack of knowledge, I can say, we are paying more electricity bill which we are not actually using or consuming it. So we should know how to use a music system in a proper way so as to minimize the power consumption. We should know how to use a washing machine. For example, okay, if in your home you're having a washing machine, and even for small load like small clothes, if you're going with a high load operation, so what happens? The power consumption will increase. That is waste of electrical energy. So here paying electricity bill is not condition. If you have money, you will pay the electricity bill. But okay, saving electrical energy and saving the environment is a major concern over here. So we should be very, very efficient to save the electrical energy. So here you can see, according to the electrical energy auditors. So who are the auditors? Nothing but the people who are going to make the tariff, or the people who are going to make the research and development in the electrical energy. So these people have said that almost like 5 to 10% of energy consumption we can minimize by changing our behavior itself. Like whenever you're going to leave the room, turn off your lights. Whenever you're not using your devices, better to keep into the sleep mode or at least go into the standby mode. So this is a main thing because of which we are paying some 10% of extra electrical energy. So by means of saving electrical energy, which will directly refer to saving money. So at last, I can say when you're going to save electrical energy, we are saving the money also. So the major appliances which we are using in home, what are the heavy load devices which we have in home? Like we have refrigerators, which we are going to use 24/7. Never we are going to turn on the refrigerators. Cloth washers, you can say, or your washing machine, dishwasher, as well as water heater also. These are heavy load devices in our home, and these are the equipments which will account for a big chunk of your monthly utility bill. Almost like 60% of your electricity bill will be because of these loads only. And if your refrigerator or washing machine, not only this thing, all your electronic devices, if they are a decade old, if it is of 10 years old, you are spending a lot more on energy than you need to. That means because of not certified from BEE, these equipments will consume more amount of electrical energy. Means which were made in 1990s or in 2005 also till this age, these equipments will consume some more amount of electrical energy because those are not configured into electronic way. So today's major appliances don't hog energy, means those equipments will never consume energy, electrical energy, the way older models do, because they must meet minimum federal energy efficiency standard. Whenever you're going to launch any device into the market, like a washing machine or refrigerator, it will be tested and commissioned. So based upon that only you'll be getting the approval, to sell your product in the market. So these standards have been tightened over the years. Nowadays, it is very, very tight to launch any new product into the market, because they have to meet the federal energy efficiency standards. So as per the LEED standard, it is recommended if you're using any kind of outdated electrical or electronic appliances, better to replace that. Go with a good manufacturing company. When you're going with good manufacturing company, what happens? The initial investment may be more, but on a long run, it will give you a good benefit. So never use any electrical or electronic model which is almost having a make more than 10 years old. Now we are going to discuss about different points. Which point will consume how much amount of energy and how we are going to use that point. First, we are talking about lighting point. Lighting means number of lamps whenever you're going to use a lighting fixture. So get into habit of turning off lights. This is a simple habit we have to change, because by default, when you're going to turn off the lights, when you're going to leave the room, automatically you're going to save 0.5% of electrical energy. Next point states that use task light. What is task light? We're going to discuss in the future classes. So task light means the light which focus on one specific area. Like you can see in my classroom, I'm having some 6 ceiling mounted lights. And in order to deliver a class, I need some illumination or brightness with some minimum amount of lux, like 250. So I have to switch on all my 6 lights in order to get a lux of 250. So to overcome the operation of this 6 lights, I can also place a light on a table which focus only on my specific work plane area, so that I'm going to minimize the consumption of 5 electrical lights. So always go with a task light, the light which focus on one specific area where you are sitting or where is your work plane. So that you're going to consume almost like 60 to 70% of your energy and take advantage of daylight also. So this is the scope of an architect, to provide natural illumination in a very well mannered. If you're having a daylight in your room, so there is no requirement of artificial light in your room. So de-dust the lighting fixture also, almost for every 2 months or 3 months. Better to go for the maintenance, because of soil formation or dust particles, the illumination may get down. So that will also consume some more amount of electrical energy. Because of no illumination, what we're going to do, we're going to install few more lights, but you're not going to de-dust the lighting fixture. So these are the points which we have to use whenever we are talking about the lighting fixtures. Now in lighting, which type of light is suitable and which type of light will consume the electricity in much aspect. So first we have the CFL. About the configuration of CFL, we are going to discuss later. I hope everyone know the CFL, the compact fluorescent lamp. the tube, I can say. So this will consume less energy when compared to your normal lamps. Okay, normal bulb is what? Nothing but your incandescent lamp. When compared to incandescent, it will minimize the consumption almost like for 75%. 4 times we are getting a difference between the normal incandescent lamp. And the life of this CFL is also more when compared to your incandescent lamp. And in this, we are having the electronic chokes. In the olden days, we used to find the electrical chokes. Even if you go with local manufacturing companies, there you can see the choke will not be of good tested and commissioned area. So that will consume some more amount of electricity. So always try to select a electrical choke or a ballast which is using the medium as copper, because when you're going to use a copper, so it will minimize the consumption for almost like 2%. And whatever type of light you're going to use, it can be incandescent, it can be CFL, it can be FL, it can be LED. Always you have to turn off the lights when you're going to leave the room. And you can see, use energy saving light bulbs. Even on the lighting fixtures, you can see you'll be finding the star labels like 3-star, 4-star, 5-star. So as you're going to increase the star value, okay, like if you're opting for 5-star, so what happens? Okay, the cost will be more. The cost will be more, but on long run, it will give you a good benefit. And you can see here, a single 20 to 25 watts energy saving bulb. Okay, that means if you're going with the good manufacturing of 25 watts of bulb, on an average, it will give you the difference of 100 watts ordinary bulb. Instead of using the 100 watt ordinary bulb, you can go with 25 watts of good quality bulb. But many of them will do, okay, they will go with local manufacturing company to minimize the cost. But that light will not give the enough amount of lumen to achieve your lux value. So try to go with good manufacturing companies only. I hope it's very clear till now. Next, you can see, save on your fridge and freezer or refrigerator, I can say. So avoid putting warm or hot food into the fridge or freezer. Okay, so whenever you're going to keep anything into your refrigerator, bring down that utensil or your container into the room temperature value. Once it reaches to your room temperature, then only keep that utensil into your refrigerator. And always try to clean your condenser coil minimum for every 6 months. And if you're going to use a old refrigerator, it is recommended to replace, because that will consume double the amount of electrical energy for the same capacity. And whenever you're going to use a refrigerator, go with the same capacity. Never overload the refrigerator. You're going to overload the refrigerator, what happens? The thermostat will not turn off your compressor, because of which it will take the same amount of electrical energy. So never overcrowd or never overload your refrigerator. And if in your refrigerator, if you're getting the ice, so try to remove that ice, because in order to maintain that ice, the temperature of the fridge will be maintained, because of which again the compressor will consume the more amount of electrical energy. Again, you'll be getting some more amount of electricity bill. And this ice or will be because of improper door seals. So always try to close your door in a proper way, or if the insulation of the door is not good, so try to replace the insulation of your door. And never keep your refrigerator into the kitchen area if it is very small. And next to your refrigerator, never keep any kind of hot appliances, like your microwave oven, range oven, or your kitchen stove. Try to provide minimum 30 centimeters of clearance space across the fridge, the back side, right, left side. Minimum 30 centimeters of clearance you have to provide, so that maximum amount of ventilation is obtained. And never cross a temperature of 40 degrees Fahrenheit for your fridge, and for the freezer 0 degrees Fahrenheit, because it is not required. And whenever you're going for a long vacation, always switch off your refrigerator and keep the door open, because whenever you're coming back, the fridge will be ready to use for you. Next, talking about water heater or your geyser. So in kitchen, yes, Mr. Fad.
Sir, what about inverter fridges? Nowadays, we are having in the market inverter fridge.
Whenever you talk about
a little bit about how they save energy, Annie.
Whenever you talk about any equipment, okay, which is certified from the BEE standard, by default, it will be the inverter based model only. So when you talk about inverter based model, it is using a pure sine wave equipments, and there is no requirement any kind of AVRs like automatic voltage regulators or voltage stabilizers. Following? the power consumption will be very minimum, even if you're going for any huge or heavy devices like your air conditions, refrigerators, and even your air conditioned refrigerators, and one more, there's a device, your dispensers, water coolers. For all these devices, these are these are using the inverter based technologies. Okay, but when you talk about the equipments which we used to use in 2005 2002, during that period, you don't find any kind of inverter based technologies. Next we talk about the water heaters, okay, or the water geysers also, you can say. So in domestic point of view, for the kitchen, for the utility area, or for your bathing point of view, never go with a temperature more than 140 degrees Fahrenheit, because it is not required. What many of us will do, we are going to heat the water more than the requirement. Again, we are going to dilute, okay, which is again the loss in electrical energy. Unwantedly, we are going to boil the water. Again, we are going to dilute the water. So insulate your hot water pipes also. Okay, go with any kind of nitrile rubber, or go with any kind of your CPVC tubes, okay, to maintain the temperature of the water. When you're going with any kind of plumbing design, there you can see we have two different types of pipe. One is hot and cold, and one is only cold. So always try to provide the water connections, your shower connections, especially for the hot and cold water tubes. These tubes or these pipes will maintain the temperature also, as well as these tubes will have the withstanding capacity to withstand till 200 to 300 degrees Fahrenheit also. And repair dripping hot water taps immediately. If there is any kind of leakage after using the taps for years and years, try to repair it, because we are using electrical energy to get the hot water. So we should not waste the hot water anytime. And whenever you're not using, try to close the tap, okay, in the full mode condition. Again, about washing machine, wash full loads of washing machine. You will use your machine less often. For a simple or a small pair of clothes, never go with washing machine. Try to provide with the full capacity and try to use the washing machine as per the requirements, okay. And don't go for high temperature rating configuration if there is no requirement. Okay, nowadays we can see in the washing machines, we are having to set the temperature of the water temperature also. So especially for the baby clothes, we have that. But if you're not going to use the baby clothes, never go with the temperature option. And also go with for the spin cycle if there is a requirement. Okay, and don't go for the tumble drying option. Tumble drying means what? Nothing but your dhobi pachad, I can say in Hindi. And if you need to go with tumble drying, try to go with lower temperature. Both the temperature value and this option, never try to set it one time, because the power consumption will. Again, talking about oven or electrical cooker. So make sure your oven door closes tightly. If it is not closed, it will not get operated. In the olden days, we used to go with conventional ovens, but now we are going with microwave ovens. Okay, because the power consumption is very, very minimum in the microwave oven when compared to conventional oven. Like in the microwave, if you're going to use for 2 minutes, in the conventional, we have to go for the 5 minutes. And keep the center of the pan over the element. Okay, exactly at the center, I can say, because exactly in the cabin of your oven, when you see, the element will be at the center. So keep your utensil or your container exactly at the center, so that maximum amount of temperature, okay, will be at the midpoint only. Only boil the amount of water that you need. Not only the water, whatever you're using in the oven, try to go with the same capacity. Never go for the higher operations or options, and never again bring down from that option to the other option. Talk about the coffee maker or your tea. So go with the options as you require. Don't go for all the options. When we talk about computers or laptops or desktop, it is recommended to go with all-in-one desktop nowadays, because the power consumption is very less. Or you can go with laptops also, because when you talk about a computer, a separate cabinet will be there, a separate monitor will be there, again speakers will be separate. So all these things will consume different electrical energy. So by default, we are going to save electrical energy of 5% if we are going to use a laptop or all-in-one desktop. If we are going to use a desktop, because if you want to work in a very rough and tough way, so we go with desktops only. So if you're going with desktop, go with LED screens. Don't go for any kind of LCD or any kind of outdated CRT tubes. And when you're not going to use your laptop, try to keep it in the sleep mode, because approximately 40% of energy we are going to save. Like your computer is consuming some 200 watts. So almost like 40% you're going to save, because when you're not going to use your CPU or when you're not going to use your computer, when it is in the sleep mode, try to switch off your monitor also, because monitor will only consume half amount of electrical energy. So try to switch off your monitor. And we think that providing a screensaver will save the electrical energy, but it is false. Screensaver will save your computer screen energy, but not your electrical energy. And when you're going to use desktop, try to provide different on-off switches. So as per your requirements, you can turn on and you can turn off. When you talk about laser prints, so it will consume some more amount of electricity when compared to your inkjet printers, but quality of laser print is very good and the speed is also very more over here. Again, talking about ceiling fan. Okay, normal ceiling fan of almost like 300 is 300 mm sweep value. So this will consume almost like 20 units of electrical energy, almost approximately on an average in a month, 22 units of electrical energy. Okay, and many of them will think that if you are going to increase the fan speed, the power consumption will increase, but it is false. But generally what happens is when you're going to decrease the speed more than the limit, when you're going to increase the speed more than the requirement, like what many of them will do, they are going to place one more capacitor. They are going to attach one more capacitor to increase the speed. It is not recommended, because the amount of power consumption will increase. If there is a requirement of speed, try to install one more fan, but never go with all these options. And if you're not going to use the fan with the rated speed, like if your fan is having a speed of 1500, but the requirement is something like 2000. So what happens? There will be the generation of heat energy, because of which again the power consumption will increase. And when you talk about regulators or dimmers, try to go with electronic regulators only. Don't go for the electrical choke type of regulators. So at last, I can conclude that whatever device you are going to select or whatever device you are going to design, try to go with a good manufacturing company. I agree that the initial investment will be more, okay, but on a long run, it will be much efficient for you, much efficient for you. And in many countries, efficiency rating labels are mandatory. Even nowadays on the transformer also, you can see you're getting the star label. Like if you go with good manufacturing companies like Toshiba, Bell, ABB, these are the manufacturing companies which are giving you the label for the devices also, even for the transformer. And this label will provide you the annual consumption of electricity information. I hope regarding this topic, it's very clear.